One strategy is to increase production and storage of photosynthesis. Actions include making plantations, but even much more important than plantations is to restore and conserve intact ecosystems. It's not widely known that intact ecosystems store carbon better than our man-made plantations. Challenge, absorb carbon from the hydrosphere, the freshwater lakes, and also the ocean. We again have to increase photosynthesis. We have kelp farms and oyster farms, and we can also restore and conserve coral reefs. And I will talk about something little known, and that is the restoration of whale populations would have incredible impact on our global marine systems. Another challenge is to mitigate the impacts of global change. We have to slow and store surface water runoff for floods. We can reconnect river floodplains with river channels. There are runoff attenuation features and also urban nature-based solutions such as green roofs and rain gardens. We can mitigate impacts of global change. We can do this as a strategy would be to facilitate movement and migration of animals and plants. We create green corridors, highway bridges, and replanting. These are nature-based solutions for facilitating the movement of our fauna and flora. We can mitigate the impacts of global change in terms of the heat islands and general heat in the atmosphere. Here again, we are very familiar, green roofs, walls, green walls, urban rain gardens, restore urban streams and river corridors, and expand regional forests. It's found that large regional forests will cool the regional climate. But to really get this story correct on adapting to global change, I strongly recommend a book by Amitav Ghosh of Kolkata called The Nutmeg's Curse, which says to understand climate change, you don't just go to the start of the industrial era, you have to go 500 years back to when Europe began changing the landscapes worldwide to maximize production and return that productivity to Europe. So this has to do with what's called terraforming. Here we have the creation of palm oil plantations in Indonesia, but we've been seeing this all over Asia and Africa and South America, as well as the other continents. Basically, this strategy starting 500 years ago has frozen nature in place to maximize productivity simply for humans. And at the same time, this has been accompanied by war and genocide in the terms that you have to empty these landscapes of people in order to have the productivity solely going toward colonial powers. Many people don't understand how productive these landscapes are in their natural form. We think of productivity only in terms of whether it delivers palm oil or other agricultural products to our urban environment. So here is a recent paper showing that the rivers in the Amazon, in being allowed to flood and move, they swing back and forth as they flood, have much, much higher biodiversity. So it's as if the dancing and pulsing of nature is an engine which produces biodiversity. And when you freeze nature in place, you're going to lose that ecosystem service of biodiversity. In Europe, we have seen here, this is the river Tisza in Hungary. And 300 years ago, this was a polyculture with over 1,000 varieties of apple and 1,000 varieties of pears. There was a an agrobiodiversity in Hungary at that time that's unimaginable for modern people now, especially people in cities. We changed a polyculture of fruits and nuts and an incredibly productive fishery into a monoculture that produces grain. This is typical of the industrialization of landscapes in Europe, in North America, and worldwide. So we also know, by the way, that it's not just that we influence biodiversity of animals. Animals, in turn, interact with the landscape. This is just one example we've now found that when we've reintroduced wolves, not only does the biodiversity of the mammals and the birds increase, but also it has changed the morphology of the streams and the dynamics of erosion. What I'm trying to get you to see is that nature-based solutions, what we're dealing with mostly are small-scale urban applications, highly successful. But to really deal with global change, we're going to have nature-based solutions at all scales, urban, suburban, landscape, and larger, if we are really going to address global change. Let me give you a very, very little known example outside of marine ecology, and this is called the whale pump. And what we've seen, is that blue whales descend from the surface 300 meters or more, a kilometer down and hunt krill. Sperm whales go 5 kilometers down and hunt squid. When these whales return to the surface, all those nutrients are brought back to the surface of the ocean. The feces and urea of those whales feed phytoplankton. That is, of course, more oxygen. It is absorbing carbon. Those are all benefits. But what most people don't know is that our fisheries globally are a pale ghost of what our fisheries used to be. So we have only 5% of the whales that we did 250 years ago. And if those whales returned, if our whale population returned to the population, there would be an enormous rebound of world fisheries because the whales are pumping nutrients from many kilometers down to the surface where there is a scarcity of iron and nitrogen and phosphorus. So on larger scales, this is a planned landscape corridor. These are ways in which we are looking to increase natural benefits as well as the movement of animals. This is larger scale than most of nature-based solutions we're talking about. A related subject, we are now finally in Europe encountering wildfires the way they are in Australia and North America. And what we have found is that the decline of rural society, which in the plenary address he talked about, is now coming home to us. What has happened as rural society declined is we lost our shepherds. And it was the work of the shepherds with the goats and sheep that lowered the fuel in our rural landscapes. So it has come to the point now, we realize that in allowing rural society to decline, the tremendous work done in our rural society, in rural landscapes, is coming back to us now with greatly increased fire danger. So in Portugal and Spain, they are starting schools for shepherds, and a shepherd is now a job in the French government. So we are trying, in other words, to go back to nature-based solutions, but notice a difference here. Here, the nature-based solution is mediated by people. So it's not just that we want to return biodiversity of animals, we have to also return the integrity of rural society such that we have better implemented, better aimed nature-based solutions. So I want to return now to this example, and that is, this is not something that a engineering solution coming from a university. This is a solution decided on by a local community in Poland with the assistance and guidance of scientists working with them to help them identify the problem of water flow, how to store water, and make a green environment in their city. So this is the concept that they together designed. They co-produced this. And as Dr. Kosla identified, with bottom-up solutions, what we need then is this integration and marrying of our nature-based solutions with reviving democratic institutions of discussion and control of resources at local levels. So in a sense, if we want to realize the full scope of nature-based solutions, reanimating nature requires reanimating society. And I thank you for your attention, and I'll be happy to answer questions. That's an extremely good question. Uh, as you may be familiar, there is a term in systems called path dependence, which means that our previous solutions, our way of thinking now, and our ability to act is very much influenced and constricted by previous decisions. And also, you might say, the infrastructure we've put in. So I will give you an example. Trying to make a river wild again, you're dealing not only with the sunk costs of the infrastructure, such as building dikes to contain the river, you're also dealing with 200 to 300 years of people living behind the dikes. So they're terrified of flooding, terrified of water, and we cannot experiment with opening the dikes and allowing a river to flood again. So you're right, mainstreaming these solutions is very difficult, not for the physical fact of how much money we have put into the existing infrastructure, for the fact that democratic institutions have declined and people are not capable of thinking outside the box and experimenting. These kind of experiments are not just something decided by the government or university. It takes all of society in order to hold hands and do it. I would, I don't have a long time. I would simply say this: the extreme nature of the heat waves we're having, and also the fire. People in Australia were chased out of their homes and had to run for their lives to the ocean, where they were saved by the Australian Navy. And we have extreme cases of fire, and people are starting to realize we must change. I believe it's going to be forced by the extremity of uh, of the events that are upon us. There is a paper back in 2010 saying that one reason people haven't reacted to global change is that the global north has experienced global change as something pleasant. Even the rich global north is no longer experiencing global change as something pleasant. But what you are asking is a much more detailed question of how to engage policy making at another level. If you will contact me by email, I'll be happy to continue this discussion with you. Yes, I would like to invite Professor Mukunda Dev Behera to address us, please. Professor Behera is at the Center for Oceans, Rivers, Atmospheres, and Land Science in Kharagpur, West Bengal. Mhm. Yes, please. If I understood correctly, oh, so you want to change the order? Okay, so yeah, I'm sorry to hear that of illness. Uh, Please swap. I'm sorry for my pronunciation. Swapnil Saxena, would you please give the next speech, please? Thank you very much.
Sure. Thank you, Jan, and good morning, good afternoon, good evening, everybody. I hope my presentation is visible and I'm audible to everyone. If somebody can let me know.
It's visible. Please continue.
Okay, thank you. So, thanks to the organizers for inviting me, and I'm very pleased to be here. I'll be sharing, the regarding the work that I'm currently doing at the United Nations Development Program and the Coalition for Disaster Resilient Infrastructure offices back in Delhi. So basically, the research that's ongoing in CDRI is on a global report on climate and disaster resilient infrastructure. It has a work stream on nature-based solutions, which I am anchoring at the moment. And the research basically focuses on the role that NBS could play to achieve infrastructure resilience and the different challenges and opportunities that one has to tackle if NBS are to achieve scale and widespread adoption. So before I move on to the challenges, the barriers, as well as the potential areas of opportunity, I would like to briefly discuss why we need to first establish the rationale for NBS in the entire climate and disaster resilience space. So, starting with a statistic here, you all may have heard about the existing infrastructure gap. It is to the tune of 80 trillion US dollars, which means that much investment, new investment, will be required globally for the next 15 years if we are to, close the infrastructure gap. And uh, you know there are member states who are signatories to global goals such as the SDGs, the Paris Agreement, etc. So the gap is far greater if we are to achieve, all the targets set out in these global goals. Uh, so there are countries which are making large investments, and there has been progress, where you know resilience of infrastructure is concerned. However, there are issues around weak or deficient infrastructure governance. There are issues around poor maintenance. Uh, uh, there are issues of financing, etc. This, coupled with disaster and climate risk, kind of exacerbates the problem. So when we talk about disaster risk, we all know that physical hazards such as earthquakes, floods, cyclones, they present a particular challenge to infrastructure systems. Between This is a World Bank estimate, and says that depending on sectors and depending on regions, between 10 to 70% of all infrastructure disruptions are disaster related in countries. So, particularly disaster and climate risk, therefore, have a major compounding effect on what uh, are often already vulnerable and strained infrastructure systems. As climate magnifies hazard and exposure, infrastructure disruptions also become more frequent they become more pervasive, they become more severe. Uh, and especially, I can talk from the experience of, the global South. Still, there are large gaps and inadequacies in how infrastructure provisioning is approached in the entire life cycle of a project. So, right from conceptualization to its implementation, there are a lot of gaps, limitations, and barriers in governance which impede the provisioning of resilient infrastructure. Another very pertinent issue is about legacy infrastructure. So, and this is most pertinent in case of power generation. We all know that states are trying to move towards carbon neutral economies, and there will be phasing out of legacy infrastructure. But that also means that there is a growing stock of stranded assets as new capital flows to fund infrastructure, um, as new capital flows to fund renewable energy and the like. So, in amidst all this, NBS have a very crucial role to play because one, the challenges are multifaceted. Second, closing the infrastructure gap will need cost-effective solutions. Strengthening disaster and climate resilience, as well as transitioning to carbon neutrality, uh, in that light, NBS seem to offer multiple advantages over conventional gray infrastructure as well. I'll quickly talk about some barriers that one observes when we try to implement nature-based solutions at the local scale. So, there are definitely governance barriers. So, siloed and dispersed governance across the national, subnational levels is something most countries face. Lack of political will uh, and long-term commitment. So, even if there is will, there is political will to implement NBS projects. The problem is that NBS projects show outcomes in the long term. So, for implementation, the political will becomes low because NBS projects do not show immediate outcomes on ground. So that is one, I would not say a barrier, but it's a challenge that a lot of countries are facing. Definitely, lack of awareness amongst all stakeholder groups. Definitely, you know, which are part of any urban infrastructure project. Within local governments who are the direct implementers of nature-based solutions, there is a fear that because there is not many evidence that has been established on the success of projects, there is that aversion of risk that what if the project fails and what if the financing doesn't translate into a fully uh, efficient project on ground. And of course, the issue of standards for implementation, operation, and maintenance, because there is dispersed governance, and also because MDS is a fairly uh, it's as a concept, it's not new, but as a term, it's a new term which has been in existence only around for a decade. And it's now that all the governments and all the stakeholders have started to speak about it. It has not effectively trickled down and translated into national policies and subnational frameworks. There are barriers in financing. The first barrier is definitely the perception that these solutions can sometimes become high cost. They are exotic in nature. That's a perception, and all because it all has to deal with the semiotics of the issue that there is not much evidence which is widely available to prove a certain claim. Then there is a lack of valuation and accounting tools. If there are tools existing, in some regions of the world, they haven't, the capacity to understand the tools, the capacity to use the tools to, understand uh, the feasibility of a project is lacking. There are The most important barrier is the challenge that NBS implementers face in financing for their projects. So both public and private investments are a big challenge. And this automatically flows into a lack of markets for products, technology, and services. So what we really need is financial incentives, and the lack of that is a major barrier. Another barrier that I see in for accelerating the uptake is barriers in data and knowledge. So the entire global community is working to produce a lot of new literature, tacit knowledge around NBS, but still the key barrier is that the understanding of NBS across the globe is very different across regions. There is lack of a common understanding. For example, I can take the example of nature-based solutions as a term itself. As a terminology, it has not been accepted widely by all countries. For some, NBS is a term that shouldn't be used because it implies, simple actions like planting of trees and doesn't encompass ecosystem-based adaptation and services, while the others make the case that it is a fairly large umbrella term. This is something that the IUCN advocates. Uh, Another barrier to knowledge in the NBS field is the uncertainties around performance. So the more evidence we generate out of demonstration projects on ground, the more we will be able to uh, address this barrier. Lack of skilled knowledge, brokers, technical capacity, and this is the most pertinent at the local level in city agencies where the implementation of projects happens. The global community has fairly advanced and the knowledge. There are many technical experts and expertise available at that level. So the challenge is really to take that expertise and put it to use at the subnational levels. Another barrier is that in the professional curriculum of education, NDS as a core, subject is still to find its way. And if that is done, I think a lot of improvements in, tackling these knowledge silos can be made. And I talked about perception and anecdotes around how this is an exotic solution. The fourth barrier is around legislation and regulation. So lack of regulation, codes and standards. Um, and because engineering solutions have more evidence. They have things like cost benefit analysis. They show the return on investment. That is not as clear in the case of NBS projects because assessments do not take a holistic approach of taking accounting for all the outcomes that a project makes, which includes social outcomes, environmental outcomes, economic outcomes, etc. So unless that is done, engineered solutions will always be prioritized over NBS approaches. So that is an area which needs a lot of work. And of course, the lack of an integrated approach because NBS, like other fields of infrastructure provisioning, require interaction between multiple disciplines, which is lacking. And somehow we have to find ways of bringing in, experts from all the sectors to jointly brainstorm on a larger strategic vision of nature-based solutions. Opportunity areas, definitely, I would like to present these 8 before you. There are many. So, in terms of costs, there are proven examples and demonstration projects which show, that there can be a cost cutting almost down to a fraction of conventional gray infrastructure provisioning in some cases. They will have far lower operation and maintenance costs. Needless to expand on the role that NBS have to play in hazard mitigation, climate change mitigation, and adaptive resilience. Uh, and of course, definitely emphasizing on the co-benefits, environmental, social, economic co-benefits that NBS have to offer, their role in reducing systemic risk, etc. And one more very good opportunity is the potential that NBS give in being integrated with cutting edge bioengineering to improve our traditional methods. So this is an area where even all stakeholders, including communities, can be brought in to create hybrid green technologies, which give the benefits of traditional infrastructure as well as new engineering methods. I would like to quickly talk about four pathways that I have sort of identified, which could mainstream NBS or could be a step towards mainstreaming NBS for resilient infrastructure. And the first one, I think, is really to position nature-based solutions as a promising climate strategy. This is nothing new. The entire global community has been talking about it. The first is really to set our strategic priorities right. And one way of doing this could be to mainstream nature based solutions into urban development by positioning them as natural climate solutions, developing knowledge and data about the benefits of various kinds of NBS, both for climate adaptation and mitigation. And if we do this, NBS will slowly but steadily gain credibility. They will, agencies will, be able to easily access resources and finance to support their implementation. In addition, the second one is aligning NBS with policies that incentivize or mandate action to address climate change is one way to, um, promote uptake. So, not looking at NBS as a standalone issue, um, but looking at NBS as something that is integrated to our larger efforts on climate change adaptation and mitigation. The third is really to make this a public mandate to facilitate cooperation, collaboration, uh, and coordinated action between stakeholders across different levels. So that includes international to national to subnational. The real goal should be about establishing those networks. And in doing so, some amount of regulatory flexibility that's possible should be created to create an enabling environment in any country which allows for integration of NBS into their infrastructure projects at the local scale. The second pathway that I foresee is, of course, investments to reduce climate risk. And the first, most important thing is to make risk information more reliable, more accessible. Of course, there is a lot of available vulnerability and risk assessment data around the globe. But what is really needed, and I would re-emphasize, is how it should be downscaled to a level of resolution that can be understood, implemented, funded, and then maintained. So, and this will require capacity at the local level to understand risk modeling, to be able to interpret it and work on risk models. Valuation of a project, attempts should be made to assess all kinds of benefits that an NBS project brings, or integration of NBS solutions to an infrastructure project brings, which includes social, environmental, and economic benefits. And in cases, I even feel comparison to gray infrastructure or similar projects would be helpful in generating more evidence. Innovative approaches such as co-financing and the role of the private sector as well as the insurance sector becomes key to driving investments. So, complementary provisions such as country ownerships, commitments, this can be done through charters, risk sharing agreements, etc., is a great way. I would like to emphasize on the role of CDRI in being a knowledge broker here. So it is a coalition of which has more than 30 member countries. So that's the sort of synergies and partnerships we have to build to be able to mainstream nature-based solutions and anything around it interrelated to it in the global discourse and at the national and subnational levels. The third pathway that I thought should be, a good addition to this discussion today is the role of integrated approaches for coordinated climate change actions. So we all would agree that climate change actions need concerted and integrated approaches. They are not specific siloed solutions. It's all interdependent. So overcoming those silos between sectors, the way in which governance operates, uh, organizing expertise in the domain uh, will all be helpful ways to ensure integration. I spoke about partnerships and synergies. So this is something which should be re-emphasized. It is critical to that the provision of large-scale long-term investments in ecosystems can only happen when a whole network of partnerships and synergies are created at all levels. Improving data and monitoring will help deliver integrated solutions and long-term sustainability of projects. And the fourth one is really to tackle the challenge of data and knowledge structures. The first one is definitely to learn by doing. So it's very important to take knowledge from one region to the other, but it's also important to sort of contextualize when an NBS action or a technology is brought from a nation to another. So this can be done through two, three ways. One, through experimentation, doing more and more of demonstration projects, but not stopping there. Moving beyond demonstration projects, if a pilot succeeds, then the next step should be to explore ways to scale it in a country. And the third step is really to take the solution and the technology to the world and let them experiment with it in their context. That is how learning by doing could be taken ahead. Another important way is to really use practitioner expertise here. So let's not let the global community definitely has a lot of expertise when it comes to how NBS can be integrated with other climate change related actions. But I also feel that there is practitioner expertise and real experiential learning that, stays with the practitioner on ground. So knowledge exchange from, bottom up is also something that could help bridge this gap. Practice-based knowledge through assessment tools, data, and monitoring. So the more we encourage, the more we bring in targets regarding NBS outcomes into the monitoring and evaluation frameworks of infrastructure projects, the more evidence we'll generate, the more practice-based knowledge we'll generate, which can be, aggregated and studied and then, shared further. So yeah, so the I wanted to not exceed the time limit given to me. So these are some of the points that I felt could add insights to today's discussion. But I would love to hear from all of you. If you can think of other pathways to mainstreaming NBS, please write to me or get in touch with me, and we can carry forward the discussion. Thank you.
Thank you, Dr. Saxena, for a very clear presentation. Are there any questions? I would like to emphasize that we have only a few minutes for questions, but it's excellent that you've provided a telephone and an email, because it would be very good if we had extended discussions going beyond the conference.
Sure.
I'm sorry, I can't see if anyone in the room, so I have no idea if there are questions. Good. There's a question.
Sure. Thank you for that question, sir. So I can, I would like to respond to that based on, my experiences on projects in India. So there are tools to gauge capacity of, you know, practitioners across different scales, including in the urban local government. But I don't think there has been, an inclusion of disaster and climate resilient infrastructure as, key area of expertise in within that training needs assessment or capacity assessment. And more so for NBS, I think it is really important to identify those indicators that could be included in a standard template for gauging capacity of an engineer or employed in an urban local body.
I thank you very much for a very clear presentation. We now invite Dr. Sudhakar Reddy to give his talk on remote sensing technology for biodiversity conservation and ecosystem restoration. Dr. Reddy, please.
Yeah. Good morning, all. I hope the slide is visible.
I can't see the slides yet.
Yeah, it is full screen. Just wait. I hope it is visible. Yeah. Thank you very much. Yeah. Good morning, all. Respected session chairman and dear friends. It is a privilege to present on the topic on the remote sensing technology for biodiversity conservation and ecosystem restoration. In this presentation, I am going to highlight the major applications which are relevant for the conservation of biodiversity and also for the ecosystem restoration. In the end of the presentation, I would like to brief on the directions as well as the challenges. All we are aware that there are several environmental issues and challenges, and there is a now consensus in majority that the Earth is experiencing a global change. And there are several studies now focusing on the planetary crisis that was mainly due to the biodiversity loss and the deforestation, increasing levels of pollution, climate change, and the land degradation. Due to these issues, now the several governments have taken up the activity of the afforestation as well as the restoration. And now we are seeing that in every part of the landscapes across the country, like in India, now the state forest departments are working on the different afforestation and the reforestation programs. They are making the lands afforested, and also they are also addressing the disasters like landslides and fires. And if you see towards the coastal habitats, there are several programs to restore the habitats to address the issue like sea level rise and storm surge. And the sustainable forest management also includes the component of the preventing soil erosion and regulation of the water flow. And as part of the concept, novel concepts like the essential climate variables and essential biodiversity variables, now monitoring and reporting of change in climate and biodiversity is feasible. And there are several global scale to local scale integrated management plans are in place. Now they are working together in development of the vegetation and also improving the livelihood conditions of the people who are depending on the natural resources. As we are aware that the 2021 to 2030 was a decade by the United Nations on ecosystem restoration. So all it is not only that the definition itself says that it is not only that improvement of the degraded lands or ecosystems, it is also to conserve the pristine forests from further degradation. And the recent IPBES report says that like of the estimated 8.1 million plant and animal species, almost 1 million species are under critical threat. In the context of the remote sensing, we have the various platforms and sensors, and they are working in the ecological domain to provide the information on the multiple components of the biodiversity and as well as the ecosystems. So there are several operational products, and there is a emerging research and development in providing the products almost in near real time. Now we are aware that there are several global scale to the local scale databases are available on land use and land cover mapping, vegetation assessment cover, discrimination of vegetation types, delineation of the plant communities, and identification of species by utilizing the different sensor data. And there are studies and emphasis by giving that on linking of vegetation with climate and also addressing the vegetation phenology and vegetation health. And as part of the IPCC as well as other negotiations, the biomass assessment and carbon pool and fluxes monitoring and uh, uh, modeling is also one of the mandate. So there is remote sensing technology also having one of the unique and pivotal role in assessing the biomass and carbon pools. And also towards the biogeochemical heterogeneity, carbon cycling, nutrient cycling, here also the ecological remote sensing is playing a major role. And towards addressing the disasters, uh, the several space agencies, including Indian Space Research Organization, is working towards the addressing the disaster risk reduction. The National Remote Sensing Center in ISRO is providing the near real-time active fire location data to Forest Survey of India, and in turn, the Forest Survey of India is providing the active fire location information within 30 minutes of the satellite pass to the different stakeholders as well as the natural resource managers. And in the recent development, there are studies, they're utilizing the remote sensing and GIS techniques in addressing ecosystem services and also in identifying biologically significant areas. And one of the criterion, because the finally the target of the biodiversity conservation is at the species level. So in this respect also, the remote sensing and GIS tools are having the significant role in characterizing the habitats, in addressing habitat vulnerability, habitat intact needs, habitat change, and the habitat degradation. And recently, in 2013, the Pereira et al., that was a expert group, they have published their novel concept of the essential biodiversity variables that is in tune with the concept of essential climate variables. And this publication was in Science in the 2013. There, the science policy experts, remote sensing scientists, ecologists, and space agency engineers, they have identified the 6 major essential variables based on 4 criteria, that is the relevance of the technology, feasibility with the technology, accuracy, and maturity of the technology. But finally, among the 6 essential biodiversity variables, the genetic composition is not achievable through Earth observation based remote sensing. However, it is having the unique importance in addressing the species populations, species traits, community composition, ecosystem structure, as well as the ecosystem function. And now there is a trend like in European Space Agency, NASA, and several like the academic institutions like University of Maryland. Now they are working on developing and producing the operational biodiversity products. And very recently, Skidmore et al. Have published the very unique list of the biodiversity metrics to observe from space. Like in 2013, we know only the 6 essential climate variables with few biodiversity metrics, but due to the rapid development in technology, both in sensors as well as in the ecology, sciences, now the technology has proven its role in identifying and reporting of change in 30 biodiversity metrics. They are like starting with the land cover and ending with the urban habitat. And among these 30 biodiversity metrics, the land cover, above ground biomass, fraction of observed photosynthetic active radiation, fire disturbances, leaf area index, snow and ice cover habitat, and ecosystem soil moisture are also categorized under the list of the essential climate variables. And in the last year, we have got a very high resolution land cover map for the entire world. It was produced by using the time series data from the Sentinel-2 imageries. They have utilized the six spectral bands and the deep learning techniques in developing a map of the land use and land cover for the entire world. And this map is available in open access, and anyone interested on the identifying the different land use and land cover in their study area, in their project specific locations, they can make use of. Yeah, yeah. Yes, sir. Yeah, thank you. Yeah. Now it is moving, like I'm showing the long-term forest cover change or not moving. Yeah. So very recently, the researchers from Impact Observatory USA, Microsoft AI, Artificial Intelligence for Earth, as well as History, in a collaboration, they worked and they have provided a map of the land use land cover map for entire world at 10-meter resolution. And as part of our national carbon project in Indian Space Research Organization, we have worked for generating a long-term forest cover change data sets. There we have utilized the topographical maps for the mapping of the greenwash, like to as a forest cover for 1930s time period. And later we have the advantage of having the satellite-based remote sensing data, like from 1972 Landsat, then the till recent the Indian remote sensing imageries from AWIFS as well as LIS3. So we have utilized this multi-sensor data sets, multi-source data sets in mapping of the forest cover for entire India and also including the South Asian countries. And here the overall interpretation is that in the last 8 decades, there was a tremendous loss of forest cover in the majority of the countries except Afghanistan, Bhutan. But however, if you see after the implementation of the national commitments like the national biodiversity goals as well as by implementation of the conventional biological diversity goals from 1992 onwards, there is a declining trend of the rate of deforestation in the majority of the countries. And in addressing the wildlife human conflict as well as in addressing the and conserving the native biodiversity, there is an emphasis on quantifying the levels of the forest fragmentation. Now there are several open source GIS packages are available. There we can able to uh, measure and quantify the fragmentation of the different study areas. And also uh, to have the information of the distribution of the various vegetation types as well as the land cover, the also we can develop by utilizing the multi-sensor remote sensing data sets. Even we can generate the information of the climatic vegetation types, physiognomic types, phenological types, as well as the compositional types by integrating the information of the structure, composition, and the functional properties of the vegetation. And another importance of the remote sensing is that we can able to generate the maps of the biomass, and also we can able to address that the improvement of the biomass or the declining trend of the biomass in a given place. And in the remote sensing approaches, we have three types of approaches. One is stratify and multiply approach. There we are having the strata like dense forest and open forest. And by integrating the field inventory information, we are upscaling the plot level information to the regional scale. Then we have direct remote sensing methods. There we are utilizing the information like the spectral vegetation indices information and correlation with the field data. And also we can use the backscattering coefficient values from the micro remote sensing data to address the mapping or estimation of the biomass. And very recently, people are utilizing a combine and assign approach. They are mostly focusing on machine learning based approaches in quantification of the biomass. As the technology is advancing, now we have the LiDAR data sets to address the three-dimensional structure of vegetation, and that is giving a very promising results in reducing the uncertainty in biomass estimation. And another important development in the field of remote sensing of forestry is that there is a product on now available on global forest canopy height map. It was produced by Potapov et al. By utilizing the LiDAR data, that is JD, Global Ecosystem Dynamics Investigation LiDAR data available from the International Space Station since April 2019. And this map also produced at 30-meter resolution. They are integrated with the pixel size of Landsat of 30 meter, and that is available in open access. And such type of data or sets are very much useful in identifying the areas of the different levels of the tree height. And now to map the community level diversity. Earlier, we have the only data sets like coarse resolution or moderate resolution, but now we have airborne as well as spaceborne hyperspectral remote sensing images. So instead of uh, going for a data collection at the plot level and then using ecological models to identify the different levels of the community diversity. Now we have the advantage of the airborne as well as spaceborne remote sensing of hyperspectral domain that will be helping us in identifying the community diversity of the landscape level to the regional level. And here we are replacing like the concept of like the spectral variation hypothesis. There, the biological species on ground are replaced with the spectral species on the hyperspectral imagery. And also, we can make use of the high temporal remote sensing data, and we can make use of the MODIS fire products in identifying the trends in or patterns in the vegetation fire hotspots. Our analysis shows that in the last 10 years, around 38% of the fire hotspots are showing the nature of intensifying and followed by the consecutive as well as the persistent. And we are at NRC also working on generating a national scale database on the distribution of the animal species and plant species. And our current target is to generate a atlas as well as the distribution maps for the endemic and endangered animal as well as the plant species. So this type of the georeference data also help us in identifying the habitat condition of the type localities of the species. And as part of our national exercise, NRC, Indian Institute of Remote Sensing, in collaboration of many academic institutions in the country, we have generated a national level biological richness map that will address the biodiversity richness at the landscape level. There we have applied the field level information in the spatial landscape model that has shown the levels of the biological richness across the country. So these kinds of maps are very much useful in utilizing and prioritizing the areas for the ecosystem restoration. And as there is an advantage of having, yeah, madam. Yeah, yes, madam. Last slide. Yes, yeah, yes. Thank you. Yeah. Now also we have the many machine learning models, and they are also available in open access domain. So once if you have any interest on mapping or modeling the distribution of the mainly the potential distribution of the species, it is maybe invasive species or endemic species. If your target is of ecosystem restoration, then we have to identify and use these types of machine learning models. Now we have like the models like the maxent, maximum entropy. They are helping us in identifying the potential habitats for the different species. And now the trend is towards a generation of new biodiversity indicators because finally, whatever the research we are generating, it should be useful for the policy framework. Now the GeoBan is working on developing various types of species habitat indices, biodiversity habitat index, as well as protection index, including the global ecosystem restoration index. Finally, I would like to emphasize that The remote sensing is at the interface of the different disciplines like engineering, geography, and ecology. And now we have from satellites to UAVs, so we'll get the information at very high spectral as well as the spatial resolutions. Now we have to integrate this type of data both in situ as well as the remote sensing observations in developing real-time or near real-time indicators for the conservation of the biodiversity. And as the technology is evolving, now this remote sensing based technology is mostly going to integrate the artificial intelligence techniques. And we are very much sure that the rapid developments in the technology is going to provide us the data sets necessary for the research and conservation. Thank you very much.
Thank you, Dr. Reddy, for a very, very detailed presentation. There will be definitely plenty to, or do we have any questions? I'm hoping the next speaker is here. I don't see their name on it, but Dr. Uh-huh. Dr. Sambita Ghosh, would you please give your presentation on systems thinking to inform design of nature-based solutions to improve resilience to climate change impacts? On my list, I see Dr. Pradeep Kalbar as the next speaker. Dr. Kalbar, please, your talk on combining nature-based solutions with mechanized solutions for sustainable water management. Yes. I have a question. Thank you very much for a very clear presentation. One barrier to nature-based solutions is the limitations of the public imagination, where they imagine the only way to deal with these problems is with machines made of steel that run on electricity. Now, it's a fascination with technology, which is technology has earned that right. But to the question is, uh, to me, it's quite sensible what you propose about integrating the two. We already have that, and somehow we have to just expand on it. But can you see that as a barrier uh, where to the public imagination, or is it a way in which the public can start, we can expand their imagination by expanding on mechanized solutions and integrating them with nature-based solutions? But thank you, very clear answer. I don't know where we are with the time. Are there any other questions? I am just regretting that with COVID, I wasn't able to attend. I've always enjoyed my visits to India, so I didn't get the excuse this time.
I can hear you. Thank you.
Yes, I can hear you. Yes, I can hear you. Thank you very much.
Moving from that, I want to emphasize. Okay.
Yes, thank you very much for your kind introduction. I'm going to share my slides. Can you see my slides with full screen? Yes. Yeah. Thank you. So my talk is about the opportunities and challenges of implementing nature-based solutions in Asian countries. So nature-based solution is a relatively new concept, and it has been recognized by the United Framework Convention on Climate Change and also the Convention on Biological Diversity. And nature-based solutions address various societal challenges and at the same time bring together human well-being and biodiversity benefits. And nature-based solutions are also key elements to post-COVID-19 pandemic recovery strategies. And nature-based solutions include a variety of approaches. And while the techniques behind the nature-based solutions may not be new, incorporating them into national and international governance frameworks for their effective implementation are new things. And the approaches that are highlighted in red colors are the approaches that we addressed in our study. So the research goals of our study is to explore challenges of nature-based solution governance by analyzing the development and implementation of nature-based solution in Asia, the East, the Southeast, and South Asian region. And in this study, governance includes national and local governance, and also the governance related to international cooperation for Asian countries. And in this study, we focus on the nature-based solution in the fields of climate change mitigation and adaptation, and also the disaster risk reduction and infrastructure. And these are the fields that were not originally referred to as a nature-based solution because the concept is relatively new in Asia, but have been widely implemented in Asian countries. So looking at the existing studies, there have been limited studies on the governance aspects of nature-based solution. And the majority of existing studies focus on possible plans for nature-based solution in European countries with a focus in your urban area. And the EU is an important promoter of nature-based solution, and it has considered nature-based solution more broadly in terms of cross-sector governance, including financing at the EU, the regional level, by linking nature-based solution with the European Green Deal and green recovery from the COVID-19 pandemic. And in Europe, there are links also between various actors, including private sector and financial institutions in the nature-based solutions. So, but on the other hand, in the other regions, including Asia, still lack studies on the governance aspects of the nature-based solutions. So studies concerning the implementation of nature-based solution in Asia are particularly limited. And in Asia, there is no regional strategy on nature-based solution, and there is limited discussion on the relationship between the nature-based solution and cross-sector national and local governance, which could promote nature-based solution more widely. Because there are many developing countries in Asia, both national and local governance and governance of international cooperation is crucial for nature-based solution. And there are few studies related to nature-based solutions governance in Asia, and Lechner's research is one of the few studies that discuss the application of nature-based solution in Southeast and East Asia and assess the socio-ecological challenges to the application of nature-based solution in Southeast and East Asia, and show the importance of South-South and North-South collaboration. And in this study, we identify governance challenges for nature-based solutions that need to be addressed in Asia by analyzing how the existing types of nature-based solutions have been developed and implemented in the region, and by identifying the governance challenges for nature-based solutions in Asian countries. And we focused on nature-based solutions in the field of climate change mitigation, adaptation, disaster risk reduction, and infrastructure. And as I mentioned, the nature-based solutions concept is still relatively new, and the term nature-based solutions is not widely used in Asia. The components of nature-based solutions are already being implemented. And in our study, we used both academic and non-academic studies and data, which are written only in English. So I summarized the result of our analysis, and this is the main governance challenge for promoting nature-based solution in Asia. So with regard to the nature-based solutions for climate mitigation and adaptation, these measures have clear links with the UN Framework Convention on Climate Change and the Convention on Biological Diversity. And nature-based solutions for mitigation are well addressed in national strategies and policies and among international financial mechanisms and donors. But on the other hand, nature-based solutions for adaptation are less clearly addressed in national strategies and policies and financial mechanisms compared to mitigation. And the common challenges are in the Asian region. There is a lack of discussion with the cross-sector strategies, such as linkage between nature-based solution and green recovery. So we found that nature-based solution for climate mitigation especially have strong links between international frameworks such as UNFCCC and have clear national strategies, policies, and international financial mechanisms. The Paris Agreement is one of the main drivers behind this development, but the discussion on cross-sector strategies such as the application of nature-based solution to post-pandemic green recovery has not been extensive in Asian countries so far. And nature-based solutions for mitigation are well established in national strategies and policies, as well as in the international financial mechanisms and among donors. Compared with other nature-based solutions, RED framework and approaches are considered to be more developed in terms of fitting clearly into international conventions and having established rules and clear links to the international cooperation mechanisms. The RED plus, the reducing emissions for deforestation, forest degradation, the RED plus are well established in the international financial mechanisms, and developed countries like Japan have been supporting developing countries such as Indonesia, India, China, Nepal, Vietnam, Laos, and other countries in Asia. So on the other hand, the recognition of and funding for the nature-based solution for adaptation are more sporadic and less well established in the national strategies and policies and financial mechanisms. The Asian countries in the G20, like Japan, South Korea, China, India, and Indonesia, have already indicated the importance of implementing ecosystem-based adaptation as well as ecosystem-based disaster risk reduction. But compared with the RED Plus, the nature-based for mitigation, nature-based for adaptation, such as ecosystem-based adaptation, have not yet been clearly identified in the international finance and donor-funded programs and projects, and amount of the public international funding provided is relatively small. So next is the ecosystem-based disaster risk reduction. there are links to the international frameworks related to the UN Office for Disaster Risk Reduction, UNDRR, and in particular, Japan is a key promoter of the ecosystem-based disaster risk reduction, so-called ECO-DRR. So some countries in the Asian region have addressed ECO-DRR in the national strategies, but there is a lack of linkages to existing national governance and measures. And compared to nature-based solution for climate mitigation and adaptation, ECO-DRR is not clearly addressed within the international cooperation, including financing mechanisms. So some countries have incorporated ECO-DRR in their national strategies, such as Japan, China, India, Myanmar, but the domestic governance and measures for implementation remain poor in other countries. And the financial mechanism for incorporating ECO-DRR needs to be elaborated and clarified. And also the developing countries in particular need both financial and technical support to properly implement nature-based solution for disaster risk reduction. So lastly, green infrastructure. Compared to the nature-based solution for the climate mitigation, adaptation, disaster risk reduction, the nature-based solution in the infrastructure sector has no official links to the international frameworks. And the challenges are the definition and understanding of green infrastructure differ among Asian countries, and the governance under the common definition has not yet been discussed. And also the measures are not clearly addressed in the existing national governance. So, so understanding and implementation of green infrastructure varies in countries such as Japan, South Korea, China, India, Nepal, but this makes this kind of a different understanding implementation of green infrastructure makes difficult to establish national policies or frameworks, and more importantly, the financial mechanisms for the implementation of the nature-based solution. So this our study highlighted the fragmentation of institutions and actors in Asia on the nature-based solution and the challenges this poses for the different types of nature-based solution. And this analysis recognized the need for cross-sector frameworks to match the need for nature-based solution with relevant actors and institutions at various scales. And it also recommended the creating guidelines to incorporate and promote nature-based solution into a local and national policy and also the international cooperation. Thank you very much. Sorry, the question is sorry, I missed the last part. So your question was, sorry, the difference between the Japan and in India, or what? Well, sorry, I missed the last part.
My question is whether Japan is investing in
Thank you very much for your question. So, so first I want to explain that even we say the nature-based solution, different ministries are working on different nature-based solutions. So, so for example, as for the ECO-DRR, Minister of Environment leading this issue, but for green infrastructure, or Ministry of the Land is more in charge of this issue, and we. So the green infrastructure is more promoting through we have the multi-stakeholder platform that invite a lot of different stakeholders, and we have a domestic platform to enhance green infrastructure, and we invite a lot of scientists, private sectors, but I cannot say that it has a already already a very good system to enhance green infrastructure, to scale up the green infrastructure in Japan, because still there are a lot of pilot project is ongoing. So yes, I think yeah, another step is also the private sector and financial institutions are also started to interested in this, investing in the green infrastructure. So so the next step is to how to matching the green infrastructure needs and also the interest of the like investors or other stakeholders. But we still need to develop domestic governance for the green infrastructure.
Hello. Can you see my screen? Yes? Good morning. Thank you. Okay. Good morning. I'm Paul, and the picture to the right is a 65-acre mining site. That was the first phase in a project that now covers over 300 acres. 18 months before this picture was taken, the area was a barren and desolate dump site. And now, after 3 years, the forest is well on its way to becoming self-sustaining. What I'll take you through in the next 15 minutes is the backstory to this project, and also to push ahead into the future to see what needs to be done to make this sort of project commonplace in India and across the planet. And hopefully put all of this in a way that allows everyone to see it through a systems thinking perspective. But before I go on, a little bit more of an introduction. As I said, my name is Paul, and I arrived in South India 31 years ago, fresh from studying ecology and forestry at the University in Edinburgh. I arrived in Oroville, which some of you may have heard of, but for those of you who have not, I'll just mention a little about the place. It started in 1968 on a barren wasteland in South India. It covers around 3,000 acres, and the overall aim is to create a town that works towards human unity. And as such, it has drawn people from all over the world. And over the years, has developed in many ways, not the least with respect to the work carried out to the ecosystem, as we have transformed a barren plateau, which you see in the top photo, to a lush green forest, which is now seen in the bottom photo. In Oroville, the main project that I'm involved in is a botanical garden, which we initiated some 20 years ago on, again, a barren plot of 50 acres. Today, it's a beautiful garden whose main mission is the conservation of the TDEF. The TDEF is the tropical dry evergreen forest, which is the local forest type of this area. And it is the one that we've devoted our lives to protecting and restoring. But there are three main activities of the gardens: developing the gardens themselves, education, and outside project work. But all of these projects, at their core, support the tropical dry evergreen forest. Our work with this forest type exemplifies the first step in eco-restoration, which is that of understanding the local ecology of the area. Baseline studies to understand species composition. In our case, the forest was actually on the verge of extinction, with less than 0.1% of the actual forest type remaining in pristine conditions. And these are solely found in sacred groves along the coast. Since the 1990s, we have had teams surveying these remnant areas to understand the species makeup and also to collect seeds for our nurseries. It's also important when you're working in ecological restoration to not only understand the ecology of the area you're working in and hoping to restore, but also to understand how this vegetation can contribute to human society at many levels. We live in a time of planetary history when the needs of humanity are paramount, and consequently, everything we must find a role to play and provide service to humans. So in that way, we need to interpret and contextualize the information we have gathered so that we can use it for communication to the relative authorities and organizations. We need to gather the information, understand the ecology, and interpret this information so that it's easily digestible for the people who hold the power to make changes. Once we have this knowledge, we need to use that information to manifest work on the ground. And much of this has happened in the Oroville forests over the last 30 years, and also with its projects over the rest of India. When we started the botanical gardens in the year 2000, we had a lot of dreams, but no real budget or income source. One of the first things we created was a native species nursery, which within 2 years started to generate an income, and from there we progressed to running landscape projects, which over time have scaled up to the point of now where we're working on significant land parcels that have the potential for ecosystem restoration. This nature park on the right of the slide is situated in the center of Chennai's industrial zone and covers 26 acres of forest and water bodies. And so this brings me back to the first slide, a project that we're doing with the Ramco Cement Company. This is the most significant project to date that we have completed. The initial phases of the restoration of an exhausted quarry mine in the deep south of Tamil Nadu. When we first saw it, this land was an abandoned and forgotten about mining area with a vast amount of fragmented rock that had been extracted in the process of mining the limestone. This limestone had been in a vertical seam 10 meters wide, but in order to extract the limestone, they carved out a chasm around 120 meters wide. To date, we have planted over 250,000 native trees and shrubs over the past 3 years. As we have moved ahead, we have learned many lessons and refined our techniques and species choices. I could spend the rest of the talk on this project, but today, the reason for showing this project is to give a sense of scaling up and the fact that projects like this are possible and happening today. This project also represents a model of collaboration between the corporate world and informed, knowledgeable agencies like ourselves. A journey of collaboration between ourselves and the Ramco company, which is committed to the ideals of restoration, not only through implementing projects such as this on their lands, but also to supporting the research work we are doing into the native forests through CSR funding, and as well as stepping up to support environmental restoration on a landscape level, which we are now starting in the town of Rajapalayam in the south of India. You'll see on this slide the town of Rajapalayam, and we've been involved in the environmental planning of this area for an area of around 250 square kilometers around the town. It's an ideal location as it's 12 kilometers from the Western Ghats. And within our planning area, there are 41 irrigation lakes that are filled from the rivers that flow out of the mountains during monsoon. In parallel to the planning process, we have also taken up restoration projects. On the slide, you'll see the town. And to the left of the town, you see one lake. To the right of the town, you see one mountain. And so we are setting up projects for the restoration of the lake and for the regreening of the mountain. We are witnessing a radical change in land use at the landscape level, which requires a shift in thinking from agencies. As urban development rapidly increases, both of this water body and the mountain will become surrounded by urban development. The opportunities are there to be taken, restoring ecological systems and at the same time providing recreational spaces for the residents of this very densely packed and rapidly expanding area. The point here is the potential to scale up. If people are prepared to think outside the box and embrace new ways of viewing natural resources, Our biggest challenge here is working with government agencies which struggle to step out of the old paradigm and move back into a new way of thinking, that we can use the resources in a different way. As we expand further, we have to look at the programs of ecological restoration and to understand the resources we have and those that we need to upgrade and develop. Nurseries, of course, are the key to any project, but without a good supply of native trees to the organization, there can be no restoration project. Upgrading skills of the various groups and organizations is also essential to ensure that right conversations can happen. And at the same time, recognizing there are already a good number of people in society who are ready and to devote their time and energy to conservation projects. They just need the opportunity. You'll see in these photos one of the project nursery we've set up with the Ramco in one of their industrial sites. Below, we're training forest department officials to recognize native species, something that was not part of their original training program, and which is rapidly becoming something that the forest department is interested in. And finally, on the right-hand side, you see the citizens of Rajapalayam who are interested in nature. And as soon as we go there and encourage them to come out and do the surveys, they're ready and willing to come with us. As this work further expands, we need to come to a network of practitioners across the country who can share their experiences and knowledge and inspire and support each other. This is the network of ecological restoration that has just been established in India. And together with them, we can explore what are the next steps that we can take to develop the skills and resources available. These are some of the next steps that need to happen, which is the deeper understanding of the historical narrative that we inhabit. How has India developed over the last 12,000 years? Where have the forests gone? And what was it like before the forests were cleared for agriculture? And then we need to look at other things, such as scaling up and creating the models and creating the plant nurseries and helping people to see that there is the potential there to restore our environment. And finally, we have to ensure that the work is meaningful, and there is a need to recognize a benchmark that expands the entire global community. The Global Biodiversity Standard is such an initiative. This was launched last year and is being rolled out across the world to offer governments, funding agencies, practitioners, and organizations the chance to ensure that the work they are doing is recognized and meaningful for the environment. That the momentum for this kind of work builds, it's essential that efforts and energies are devoted to training knowledgeable people who can certify projects and consequently build the confidence that this kind of work meets certain criteria and standards. In conclusion, I hope to have shown in this short presentation that there are various steps to eco-restoration and the scaling up of the work. Right knowledge and understanding of the ecosystem that you're working with. Good plant resources, i.e. native tree nurseries, set up from seed collection by many individuals. Successful experience of scaling up. Each project needs to scale up after the success of one before. Clear communication and the building of human and institutional resources. Network, and finally, the adaptation of certain standards, certifiable standards that inspire confidence from non-experts who are involved in the funding and proposing of the project. Thank you very much. Yes. Thank you, Girish. Yes, the evergreen forest is very much, in a sense, it's a secondary forest. But within the species complex, where we have around 150 species of trees and shrubs that are part of the ecozone that we live in, we can select within that a number of species that are very good for example, the mining site. So we have around 70 species of trees, including a number of ficus, a number of acacias, and a number of other species that are very good for the initial restoration. But what we like to do is plant a dense mix. So we plant a series of seedlings that is some are taller and some are shorter, and we basically try to create the multi-layered effect of the forest within the first 2 to 3 years, and that has proved very successful. I avoid talking about Miyawaki, but what I do talk about is very dense planting, and in that way we can create and we can get all of the species in the first mix. And once we've got the species in there, we head towards the moment when nature takes over and that seeds are produced and that the vectors of dispersal get in there and move things around. And we're finding that very quickly those species are arriving, particularly the birds first and secondarily the bats. And those species within 3 to 4 years, there is actually regeneration happening under the closed canopy. We have, of course, we have documentation of the work that we're doing. Yes, I'd be very happy to share that. Yes, yes. My email is there. Thank you. Perfect. Thank you so much. Again, I think the key to every plantation is diversity. When we're looking at the majority of plantations that are happening on a government scale at the moment, we're looking at 10 to 15 species. The projects that we're running and that we're promoting, we're planting 80 to 100 species. And any time that you're talking about climate resilience, we're looking at long-term changes over the next 30 years. So by mixing in species, you're creating a very resilient forest. And again, we don't know how the climate's going to change in these different areas. The project that I showed you in Pandalguri is in a very rain deficient area. It's 600 millimeters a year. And there we're planting in, like I said, a mixture of acacias, which are the natural forest of that area. But we're also adding the evergreen, because I think we don't know how the forest has changed dramatically over the last 10,000 years. We have no real records of what India was like before humans came. And we don't know how soon the forest was cleared. It may have been something like 2,000 years ago. But so what we need to do is mix the species from the different ecotones into these plantings so that the project becomes more resilient to the changes that may occur in the future, where rains may get heavier or actually may get less.
Hello, 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 mic check. 1, 2, 3. Hello, mic check. Mic check. तो आइए ना, ऐसे ही करना। नहीं, अब दोनों ऑन कर दिए। दोनों ऑन। हेलो, 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 माइक चेक 1, 2, 3. पहले तो हमने ये अब आते हैं। प्रॉब्लम क्या है? मेरे लैपटॉप से ही आउट जा रही है ऑडियो की। अच्छा, तो वो रीजनिंग करती है। अब वहाँ से आपने क्या स्लो किया? मैं एक लैपटॉप आप अरेंज करा दो तो मैं उसको
Hello, check. Hello, 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 hello. Hello, check. Hello. Oh, चलो चलो
Aadhaar, take National Digital Health Mission. How do we evaluate whether they meet the ethical standards and the privacy standards? I think that's a big question, right? That what do we need to test, or what is the test that they meet the standards or not? Data protection bill. It has a list of, it is a wish list, so to say, that there's collection limitation, purpose limitation, consent, fair and responsible processing, and so on and so forth. Now, these are, in terms of English words, they're understandable, but their actionability is sort of limited. When you say purpose limitation, what exactly do you mean by it? Or when you say consent, what happens to me if I don't give consent? For Aadhaar, do I stop living? Is it even a choice that not giving a consent? And how do I understand what is informed consent? Even as a computer scientist, I don't understand what are the consequences of that consent. So what is even the meaning of asking for consent? There's an echo back in the mic space switched off, please. What standards should we measure? So when I'm designing an application as an engineer or as a bureaucrat and I'm unleashing a digitization system, what should I look out for? What is the minimum standard that I'll adhere to? And I think that this operational definition, without this operational definition, we will continue to talk past each other. The proponents will say that we have taken care of privacy and ethics. The opponents will say that you haven't. And we'll debate in the courts. And that's sort of suboptimal. So any digitization that you do and any AI environment that you run, there is some risks. Right? There are certain risks that are inevitable. And unless the risk is precisely modeled, and also the benefits are precisely modeled. So there is often the public good with AI and digitization is speculative and it's a promise. So unless both those things are properly modeled, it is impossible to balance one against the other. And the proportionality tests that came out of the privacy judgment, I don't see how that can even be applied unless you precisely model the risk and precisely model the benefits. So in many of the applications, the way I see it is that both are inadequately modeled. That there'll be a lot of benefit out of the data. But what precisely, may I ask, can we write it down in 10 sentences? And what exactly are the risks? So somebody says that if data is localized, risk is gone. If you have encrypted, risk is gone. If I have anonymized, risk is gone. Right? But these are known to be uncertain technologies in computer science. This is not the way to discuss. This is not the way we discuss risk in computer science at all. So to be able to apply a proportionality test, we need to do better. We need to model the exact privacy risks and so on and so forth. For example, in computer science, we understand that anonymization is near impossible. We celebrated 10 years of de-anonymization last year in the journals of privacy and security. Yet the data protection bill talks about anonymization. So, there is an incongruity in the approach that we must bridge. Right? Also, if there is a bias in data, there is a potential for discrimination. What are the exact tests that I should do to make sure that I have taken care of it and the system is no longer discriminatory? So these are things that both researchers and the designers and the deployers should all look at, including the civil society. Right? And, so we need to come up with what is called a threat model, a privacy threat model, or an ethics threat model. So we need to precisely model that who are the opponents, what are the kind of privacy threats and privacy harms that can come. And in computer science, the way we do it is we model an ideal functionality. So we assume that if there is an ideal implementation, perfectly secure implementation. Don't worry how you make it, right? Then the system cannot leak any information. The only way it leaks the information is through the interfaces, through interaction with the actors. And that is a minimal privacy risk, right? There's a minimal ethics risk that can come up, depending on what is the information that is being exchanged with the actors. And it is the ideal functionality that defines what is the minimal risk that an application entails, right? And which can then be weighed against the benefits to see whether the adequate due diligence has been done. And these are the systems that we have to move forward with. So if we bring digitization to public life, we cannot possibly leave the rigors of computer science behind, right? And I think that some of the applications, the way they are being discussed, or the discourse, or the language, or the grammar, are they don't have the rigors of computer science that we are typically used to. So I'll stop here. So I'll leave it for others to reflect, and I'll try to ring a bell if there is they overshoot 10 minutes, and I'll have to probably leave at 4:15. So I'll quietly drop off at 4:15. So I think that the first speaker is Smriti Parshira. She'll speak on ethical concerns related to facial recognition. Over to you, Smriti. You can introduce yourself. Smriti, we can't hear you. I can't hear you.
Oops, I'm really sorry about that. I was on mute. Sorry about that. Thank you, Professor Banerjee, and thank you to the organizers for having me in the session. I'm Smriti. I'm a fellow with the Cyber Bricks project hosted at the FGV Law School in Brazil, and I'm a PhD candidate at IIT Delhi. What I'll be speaking, as Professor introduced, is questions around the ethical concerns around facial recognition technologies. I have a slideshow. Give me a moment. I'm going to try and run that. No, I'm facing some trouble, so let me just talk without the slideshow. Basically, I want to start by giving an introduction. We hear these terms: facial recognition, facial processing, very often being written about in the media. We know a lot of applications are out there. We are using them very often. So I just wanted to start with a very brief introduction. I'm deliberately using processing in this presentation as opposed to recognition, because recognition is one type of analysis that can happen out of the broader ecosystem of facial processing, which is basically about when you have an image or you have a live video. The first step is to first detect whether there are human faces in that, and the second is to draw some kind of patterns out of it, so extraction of patterns, and the next is the analysis which is done on it. So that can be things like emotion recognition, it can be recognition in terms of identification or verification of people, or it can be other kinds of analysis like age classification of the person or gender classification. So these are a whole suite of things which are already in operation, where the different kinds of facial processing is being seen. And just to give a few examples, we know law enforcement is one of the most talked about use cases. It is one area where facial processing is pretty rampantly being adopted all over the world, including in India. There are proposed projects as well as ongoing one in several states where facial processing is being deployed. Many other use cases, and if you broadly try to think about why, what is the justification being given for the adoption of this technology across contexts, there are reasons like efficiency, which will often be given. There are reasons like convenience. In the COVID context, we saw reasons like the contactless or humanless touch, so the ability to monitor whether someone is wearing masks or whether someone is, following quarantine rules by mandating them to take selfies of themselves inside their house. So these are some of the use cases which we've seen. We are seeing KYC happening through facial processing, where you're sitting in your home, but instead of going to a center, the person will come to your house, or you're able to do your liveness detection on your own phone, and that's another kind of use of facial processing. And then we are seeing this application in several sites, right? So we're hearing about adoption of facial processing in schools, which is perhaps one of the most problematic, sites where such a technology can be deployed, given that we are dealing with minors, we are dealing with the most sensitive kind of biometric technology, which is your face, and therefore, in all of these contexts, if you break it, you hear the justifications which are there. It's about, you need to monitor attendance of teachers, or you want to monitor attendance of school, or you want to monitor whether the students are paying attention, and there's talk about monitoring their expressions and emotions to understand whether they are really understanding what is being taught. And even as I say this, I think it's kind of obvious why all of this is really worrying, but I wanted to demonstrate some of that by going into a little bit more detail about the ethical concerns around facial recognition. And here is one, sorry, you can't see it, but I wanted to present, one extract, which is from the handbook on facial recognition, written by the technical community. It's a few years old, but it's basic computer scientists, engineers talking about what is about facial recognition, which is, good in terms of a technology, and why is its deployment useful. And basically, I'm reading the quote, which says facial recognition has several advantages over other biometric modalities like fingerprint and iris. Besides being natural and non-intrusive, the most important advantage of the face is that it can be captured at a distance and in a covert manner. And as you read this or you hear this text, you can really understand that the same reasons which make this, an acceptable and advantageous technology for the entities deploying it and for the people involved in the technical development, the fact that, it's kind of easier to do this, you don't need to go after people for consent, you can do this covertly, you can capture faces at a distance, etc. Those are the very reasons why this is a problematic, worrying use case. Certainly from a privacy perspective, which is often the first highlight which one hears about when one thinks about facial processing technology. But the ethical concerns, if you bucket them, are actually broader. So, and these have been documented across toolkits, across various self-regulatory codes that companies have come up with themselves, in national AI strategies that countries have come up with. Basically, the first one would be around questions of privacy and civil liberty. So, just as I mentioned, the ability to, given your face is permanent, it's immutable, and after that, the fact that someone can capture this at a distance without your knowledge or your consent, that raises a lot of concerns from a privacy perspective. There are transparency issues, given that very often you don't know who is deploying this technology, where it's being applied, what kind of training data went into the development of that technology, and even after a technology is deployed, what happens to those data sets afterwards, what kind of mission creep can take place, what further uses can take place. The other part, which I will focus a little bit more on in the context of a recent paper we put out, is questions around accuracy, fairness, and bias. Often these issues are intermeshed. The basic concern being that we don't know how well does this technology work, and when it works, how well does it work for different demographic groups, because inherently we know that in a lot of AI, anywhere where data input is going in, the output is dependent on the quality and the nature and the volume of that data. And very often, that's been demonstrated in research in the context of facial processing, that notably in the work called Gender Shades by Goldwani and Gerbru, which shows that in the US context, research from the US found that, when they tested the facial processing technology on a host of faces, the results for females with darker skin were much poorer. So the error rates in that demographic group was much higher. And since then, there has been a lot of work with people trying to replicate that methodology in other contexts. And I'll just briefly talk about something similar that we try to do in the Indian context. And the last 2 points before I get into that paper is, questions around procedural safeguards, or the lack of those, as Professor Banerjee was just talking about in his talk. The absence of a law in India on data protection, the absence of redress mechanisms, the absence of accountability mechanisms, and finally the structural context in which a lot of these technologies are being adopted. Whether if tomorrow Aadhaar says I want to do facial recognition to give you entitlements, is there structurally a power equation where a consumer can say no, I don't want that to happen? Or in a school, if this is being deployed, can a student really get up and say to the school that I don't want this this technology to deploy. So there are structural questions besides questions inherent to the civil liberties and the technology itself. And with that, I want to just briefly talk about some of the findings from a paper that we put out recently. This is work co-authored with Gaurav Jain. The paper is called Cinderella's Shoe Won't Fit Saundarya. As you get the drift, we're talking about how the application of this technology varies drastically depending on the context in which it's being deployed. And what we do is that we took a data set, we went through the website of the Election Commission of India, where candidates who stand for elections, their images are put up on that website along with its certain information like their self-disclosed gender, their self-disclosed age, which region they come from. So we took that information for a certain period and created a data set, a clean data set of about 32,000 images. And then we run this through 4 commercially available facial recognition tools, which were Amazon, Microsoft, FaceX, and Face++. We basically try to audit to see how do these tools perform on Indian faces in terms of their ability to detect one face in the image, the ability to classify the gender of the person, and the ability to predict the age and how closely does that match with the self-disclosed age of the person. And I just wanted to, since the topic is around ethical consideration, I just wanted to highlight the ethical dilemmas that we ourselves faced as researchers while doing this work, and actually the lack of amongst the other researchers that we tried to speak to. So the big question was, given that we are using publicly available data, which is on the Election Commission's website, what are the safeguards that one needs to ensure while still, accounting for the privacy of individuals, etc., in that process? And the responses when we spoke to people really varied. One set of researchers thought that once it's in the public domain, it's completely fair game and anybody should be able to do applied research on that. And the other, highlighted issues of contextual integrity, that it's being put out for a certain purpose, certainly not for the purpose of being run on a facial processing system. And trying to take into account all of these dilemmas, we try to build some checks and balances in our studies, such as not releasing this data set, not putting it out in the public domain, not using any representative images in our study, etc. We explain this in more detail in the paper, but I just wanted to highlight that when we want researchers, or if we expect researchers to dwell into some of the ethical considerations around this, there is serious limitation on our ability to do that, given that we don't really have robust data sets of Indian faces which are well labeled, which are well representative of the diversity of India. And then there are these, very important first order questions about the fairness of using data which was put out in a different context for a different purpose, even though in this case it was to highlight the problems with such a technology. Very briefly, unfortunately, I'm not able to show you the results, but I'm just going very briefly over the findings in terms of gender classification. So, as I said, we did 3 things, but I'll just talk about the gender results, and where we basically tested when men and women disclosed their gender in the findings, how did that match with what the tools found for them. And for all the 4 tools, as one may expect, we found that the performance for the classification of female faces was poorer, and this ranged from a little less than 1% in the case of Microsoft to about 14.6% in the case of Face++, which is a big Chinese company. And the other thing that we did in this study was, so some of these tools have been tested by other researchers in the context of other demographic groups in other countries. So Face++, Amazon and Microsoft were among them. And for Amazon and Microsoft, we found that the error rate for Indian females were kind of comparable with that of other nationalities, but for Face++, the difference was really stark. So the last study done in 2019 with that tool, am I out of time? Yeah, okay. All right, I'll just conclude by saying, so the finding that we had out of this is that, so we found that there were stark differences, that the performance on Indian female faces was poorer than it was found on a data set of African and European faces. So there are clear demographic group specific variations in the tools. There is a lack of transferability of findings from one context to another, making it all the more important for having research which is rooted in the Indian context. And I'll just conclude by saying that although we focused on accuracy in this paper, we do highlight that accuracy is just a necessary but not a sufficient condition for the adoption of these technologies, and it can in fact sometimes even backfire with governments saying that because something is highly accurate, it becomes all the more reason to adopt it. But there are so many other issues with the technology. So I'll stop with that. Thank you.
So maybe we can have one or two questions from the audience.
Hi, Smriti. Can you hear me?
Yes.
Okay. Yeah, very nice work. So I am just a little curious about like what kind of discrepancies you see even within the Indian context, because you have this data for different actors in different states as well, like different political people in different states. So do you also see some state-specific variations?
So we did, one round of that. We attempted to do that. It's not in the final paper because one, the data was not adequately representative. There were some areas where more rounds of elections had taken place. So some states were overrepresented in the data. So we did, some of that. We didn't find clear patterns, at least with this data set, in terms of where it's performing worse in certain states versus others. So we didn't finally include that in the paper, but we do point that as a necessary further direction for this sort of work. And similarly, we also were interested in trying to, look at how the performance may vary for certain SCs and STs within that group. But again, because in all the entries, it was not clearly disclosed. So some of the candidates did disclose their status, some didn't. So we were worried about, making false kind of assertions. So we excluded that again from the results.
Thanks.
Thanks, Smriti. Are there any other questions? Or maybe we can take a very quick one. No? Okay, then thank you, Smriti. That was excellent. And so the next talk is by Professor Rajat Khaturia from Shivnadar University. And he will talk on data as a public good, privacy and ethical concerns. Professor Khaturia.
Thank you, Professor Banerjee. I hope you can hear me. Isha is putting up the slide. Isha, thanks. So I'm going to start the presentation and Isha will take this forward. We'll basically start off from where you left off in your conversation. Smriti's sort of research is very specific, so we are not going down to that level of detail. We'll talk about two things, and then Smriti will talk about the implementation and the law. I'll talk about two things. One is data as a public good and the problems that are likely to arise because of the lack of a definition of what a public good could mean in the data space, that is contextualizing public goods in the received of data in the received wisdom of economics. And I think that there's a problem there. Although we don't really need to classify it, but we're trying to classify it in this paper. We will have the paper out soon, although the outline is ready, the paper is not ready yet. And the second thing is the valuation aspect, because valuation is important.
Sorry to interrupt you. Can you just make this your slide full screen?
Okay. Smriti, sorry, Isha, can you go to the next slide? Isha?
It's not moving to the next slide on this, if I go to full screen.
Okay. You can't take it to the next slide? Okay.
I just do the...
Just
mute it.
You can share your screen and first, yeah.
Is it moving now?
No,
yeah.
But it's moving.
Okay, wonderful. So, as I said, the first task we wanted to undertake is to try and contextualize how do you define public good with respect to data. So the way we define public goods is in the traditional economics literature is non-rivalrous and non-excludable. And you have examples like a village road, which becomes a pure public good, or defense services, which become a pure public good. These are the classic examples in textbooks or the lighthouse, which are both non-rivalrous and non-excludable. So the question becomes, do we need a new sort of framework to classify data as a public good? Because data has characteristics that are both non-rivalrous and non-excludable. But even so, I think it's a problematic in the sense that you can exclude it by, there's several mechanisms to exclude. One of the mechanisms to exclude data is by pricing it, or by law, legally not giving access to that data. So there are ways to exclude people in accessing the data, but once the data is there, it becomes difficult to then to make it rival. So it becomes non-rival in the sense that people who have access to that data, one person's use does not diminish the use for another person, although people could use it differently, as Smriti was hinting at. Data could be used differently by different people. I mean, just like roads can be used differently. You can drive different types of cars on roads when you have access, even to a toll road. You get access to a toll road. You can drive different kinds of vehicles on the toll road. When you have access to data, provided you have access to data, you can use it the way you want to. You can probably derive different kinds of values from it depending on who's using that data. So that's one way to classify it, but it doesn't become like what a lighthouse is in public economics. Data doesn't become that to this discourse on data as a public good. So I think, there are two ways of looking at this. This could be sort of much more in trying to build a framework. Do we use the existing sort of framework of non-rivalry and non-excludability to define data? And I think it could fit into one box. If you press me, or if you press us, we could fit it into one box, which is it is excludable, but it is non-rival. But it doesn't really sort of address the issues because data has so much variation. And I think the Economic Survey of India tried to talk about data as a public good and, for public benefit. Like Professor Banerjee is referring to Aadhaar, there's huge amounts of benefit that Aadhaar has conferred on people in terms of welfare, in terms of both, consumer welfare, in terms of government reduction in costs, in transaction costs. There's a huge amount of welfare benefit that has come, but there are also costs. So in all of this discourse, I think we are always going to be in what economists call the theory of the second best. We are always going to be in the second best world, and therefore to try and design policies which are, which you can implement in any sort of meaningful way, it will become very difficult. So we will be in what I said, the second best world. Even so, lots of policies are made in the second best world, which is with little information. Here you've got, surfeit of information. In some sense, you've got surfeit of data, and you are prevented to use it because of ethical concerns, because of risks, etc. So you're in an alternative paradigm. You've got surfeit of data, but there is, in some sense, and you are restricted to use it. So we don't have a conclusion here. I'm trying to establish a framework. I think the Economic Survey tried to do it in 2019, but I don't think it went whole hog in terms of being able to come up with the framework. We're still there, which is, do you use an existing framework of a public good to try and initiate this discussion, or do you try to establish a new framework which accommodate data as a public good in dialogue and discourse? So I think the question is still open. We don't have an answer to, but we will try. And it's like, to use a simple example from the trade literature. I'm a trade person, so I have examples from the trade literature, which is that when trade in final goods was happening, you had the Ricardian model of trade, you had the Hexagon model of trade. But suddenly, when component trade began to happen, when fragmentation of the value chain began to happen across the world, where parts of a computer are produced in 50 different countries, people said, "Oh, gee, the old theories of trade would not apply to this new kind of trade, because the old theories only talked about trade in final goods, and now you're talking about trade in components, which are so minute, trade in tasks, etc. The old theories would not apply." But the result of that was, the old theories of comparative advantage and competitive advantage did not need to be sort of changed to accommodate this new kind of trade. The old theories was sufficient, or the old framework was really sufficient. And that's really the question Isha and I are asking in this paper, is that do you need a new theory, or is it enough? So it's in a sense, it's an intellectual exercise, but I think it's fair when you're talking about markets. You do need to talk about public goods and market failure. So I think that's the first motivation for this. And the second motivation, Isha, if you can move on, is really to try and value, because this is the other term that has become so popular in the discourse. One term, as I said, data is a public good. It's used, abused. I'll give you a couple of examples. And Professor Banerjee had already begun to give those examples, and I'll give you a couple more. But this is an abused term, data as a public good. And the second abused term, which is not on our slides, but which everybody in this discourse knows about, is data is the new oil. And if you talk to activists or NGOs who work on consumer, on the consumer side, they will say, oh, data is the new toxic. And I guess both are right. Data is the new oil, data is a toxic, but what is the value of data? It's very difficult to sort of talk about valuation. What is the value of Aadhaar, for example? If I were to do one characterization, and say, well, if Aadhaar is going to be used for direct benefit transfers and to open bank accounts, what is the value, what is the amount that the government has saved by instituting the system? That could be the value of Aadhaar. I mean, that's one way of looking at it. And the government has put out statistics saying that they've saved thousands of crores in economic costs and transactions costs. And Mr. Nilikani is talking about deduplication. And I think that is one of the benefits of Aadhaar, deduplication. So that is one way to sort of begin to try and value this good that you're talking about. The second, the value that you can do is look at data-intensive companies and say, what is the valuation of those data-intensive companies on the farm? So that could be one way you could.
Professor Kathuria, I think that we are in the 10-minute.
Okay. So I am going to now stop here. So the two questions that I have referred to, or two points that I have referred to, are really data as a public good and the value of data. And both these, I mean, we are far from being able to give you a firm conclusion as to where we are headed, at least in the scholarly world. Isha, over to you on the law and legal aspects.
So in the interest of time, I'll just skip quickly to our recommendations, which also will touch upon the sort of we'll also touch upon some of those issues that Professor Banerjee highlighted, where he talked about that it is well known that there isn't an irreversible anonymization that can take place. So within those sort of frameworks, what is it that the legal ecosystem can do better? On our slide, you see a couple of case studies which precisely pinpoint this. There was one in 1990, and the reason why irreversible anonymization is not able to happen is because correlation has become so easy, right? You even if you de-identify a particular data set, you're able to correlate it with the other information that is lying on the internet, and based on that, it becomes very easy to uniquely identify a person and thereby profile that person and all the ethical and privacy harms that accrue thereof. So there's a 1990 case study where a researcher did that and found that only 87% people in the United States had 4 features that made them unique. And similarly, this Netflix example, I think, is pretty well known, where researchers demonstrated that you just need 8 movie ratings, and they correlated with IMDb rating, and based on that, they could de-anonymize or identify who had rated what movie. And because your digital fingerprints are so unique, you could also tap into a person's political motivations, and risk profiling and political profiling became very easy thereafter. The next slide is about and I specifically put this slide about Department of Health in Australia de-identifying longitudinal medical health records, and how researchers there could establish a few mundane facts were enough to isolate an individual and look at their entire history. This is also juxtaposed with chapter 4 of the economic survey that Professor Kathuria was referring to, wherein the chapter 4 makes a reference to how anonymized data can be sold from the register to private parties for analytics, and the kind of harms that come along with it. If a few mundane facts can isolate an individual, this is sensitive health information, and the risks therefore are much higher in this regard. Quickly on the way forward, I think this has been discussed ad nauseum how a robust data protection legislation is imperative whenever we are talking about data sharing frameworks per se. And even the WDR report in 2021, which talks about using data as a public good, specifically makes reference to how sound and robust legislative processes are important if regulators are thinking along these lines. Secondly, economic interests cannot be pursued at the expense of personal privacy. This is specifically made reference to with the non-personal data report that came out in 2021, the revised NPD framework, which talks about sharing of data. They bring in the concept of community data, which we'll be going to in another 2 minutes. Whenever we talk about data concentration and agglomeration, the other thing that a lot of policymakers point to is that the big tech and the monopolies they enjoy by virtue of the combined data power they hold. We argue that the remedy for that is in antitrust, probably at this point in time, because you haven't been able to accurately estimate the value of data. You don't know at which precise point that inferred data becomes valuable to the firm in question. So maybe the antitrust measures that you and other regulators are looking at, the Digital Markets Act, or revising a merger control regime, where you try and look at the framework, whether it becomes an essential barrier to entry, at this point in time seems like a more sound approach than going down the road of mandating data sharing.
Isha, back to Russia.
All right, just the last slide, I promise. This particular thing, which Professor Banerjee also said, is that what is that framework within which we could, frame these questions? Some of the things that we feel could help is one, asking the question: is it imperative to release the data? Can you release aggregate statistics instead? Location information is nearly impossible to de-identify. Is it absolutely necessary for you to be, sharing location information? Can you have and test implement processes for de-identification and evaluate how accurate or inaccurate these are? And lastly, you also have to invest in research that is ongoing, and researchers have taken it upon themselves to test the efficacy of some of these anonymization measures. On community-owned data specifically, I feel the NPD probably tries asking the question of whether a group right exists or community rights exist, but we feel that the framing or the definition of community at this point in time is not clear. And by that, we do not mean members of indigenous communities who identify as part of a community as such. But apart from that, the NPD one report actually said if people using ride-sharing form a part of a community, and we feel that may not be true, or that may not be an accurate representation. Lastly, there is also another thing that alternate measures could be explored. There are data scientists in other jurisdictions who are talking about, say, synthetic data or data pooling in sandboxes, where you do not have to share the raw data with various companies, but you could have a curtain behind which processing happens and raw data is not shared. That may minimize harms that exist. So that was it. I'm sorry for rushing, but we'd be happy to send you the slides if you're interested, and these are our coordinates. Happy to sort of get in touch.
Yeah, so we can take a couple of questions for Professor Katuria and Isha. Maybe then I'll have a comment. Are there any questions from the audience?
Thank you, Dr. Katuria and Dr. Suri, for enlightening us about these data policies and all. This privacy and ethical concerns are different for different domains, right? Are you able to hear me?
Yes, we can hear you.
And for example, you take academicians or scientists are looking for benchmark data, right? So, I mean, you take, for example, Landsat data, a satellite data, which is, and they claim that people are making more innovations using that private data, using that data. Why can't we do like this in other domains also? That's my question. Thank you.
Yeah.
Isha, do you want to?
Yes, I could step in and then you can jump. So, and there was actually a slide which specifically talked about it. The lines between personal and non-personal data are getting blurred. The open data that you talked about, say data that doesn't identify or is identifiable of a person, right? There are no privacy harms there because it's related, say emission related data, weather forecasting data. Those sort of harms may not apply there. But when you look at some of the other domains, the harms and risks are very high. So you cannot open that data just like that without doing a risk assessment and then having proper framework within which you share that data. You cannot really be prioritizing economic interests over some of those harms.
Yes. I don't know.
Any other questions?
Yeah.
May I ask a question?
Yeah, sure. Go ahead.
Yeah. So this is around, so a lot of the philosophy behind some of the proposals we are, seeing in India is not about open data, but about some sort of opening of data, but with a gatekeeping function being retained. So it's not open in the true sense of it's open to anybody to use it, like you would call it, the public good idea of it. But this idea that, we don't want big tech to access this open data, it's about open data for the development of Indian industry and Indian entrepreneurs. Do you account for that somehow in your methodology, that gatekeeping role? Like, how does that fit into an economic analysis?
Isha, should I? Or would you want to?
You take the first stab and I'll just jump.
Okay. So, Smriti, that's a good question. Why has this happened? I think this has happened because, this is the question of which has happened because of legacy, I think, rather than having a perspective on how different people will use open data, how will small companies or startups use data, and how big tech will use data. The thing is that big tech will use data, the accepted wisdom or hypothesis has become big tech will use this data for its own benefit rather than for the public benefit or public welfare. That's become the accepted wisdom or the accepted paradigm. And therefore, I think that question, there's nothing preventing people like Amazon or Google or Meta or Facebook to use that public data, publicly accessible data for welfare. But I think people are suspicious so much about big tech or doubt their intention so much. So this question has come up. But if it could be analyzed on a case-by-case basis, because there is some public good that could come out of big tech analyzing public data, because small people, small innovators will not have a wherewithal to do that. Let me give you an example at the cost of time. There's this innovation that is happening in America, and the way Google gives you Google Maps is that it takes them 3 years to collect that information or 4 years to collect that information and put it out in their Google Maps, so that when you're driving, you're able to say, okay, this road is crowded or this has potholes, I'm going to take an alternative route. So there is a public benefit there, especially to drivers. But now there is an innovation, a small startup in California. You can fit a camera in front of your car, in the bonnet, below the bonnet in front of the car, and you can get access. You will be providing this information in a public way to anybody, because all these cars will be linked, whoever agrees to do that, and data, that's public data, that will be de-anonymized.
Professor Ghalib, I have to cut you
and that will be available to everybody. Now, what can they do as good as a job as Google is likely to do? I don't know, but these are innovations that are being used. But I hope I've answered your question.
Yeah. So maybe let's invite the next speaker, Abhinand, my colleague from IIT Delhi, and he'll of course talk on ethics of AI. Over to you, Abhinand. Are you there?
Yes, I'm here, but I don't know whether you can see me.
I can see you very well. Yeah.
Okay.
We've got 10 minutes.
Okay, sure. ये वाला है
And while he's getting ready, maybe two comments for Isha. First is that there is no guarantee of anonymization with aggregated data. After all, the 1990 US Census was aggregated data and it was completely de-anonymized. And in fact, the 2021 census, by the way, is also de-anonymized. Though the data is not released, but they have put differential privacy standards to protect that data. And there are at least 100 algorithms that will say that the moment the data is out, some say within 30 seconds, some say within half an hour, the 2021 US census will be de-anonymized. So the algorithms for de-anonymization are already and waiting. So there is no guarantee that aggregated data is safe. That's a mistake. Second is when you talk about privacy violation of AI, it's not even in the input. It's primarily in the output. And so even if you keep federated learning, the inferential privacy cannot be bounded. So there is no guarantee that what you will infer out of the data because of correlations. So those are 2 points from your slides. Yeah,
Yeah, hi.
Thank you.
I'm Abhigyan Chakravarti. I'm a faculty member in the Computer Science Department at IIT Delhi. So today I'm going to talk about fairness in artificial intelligence, and I'm going to specifically focus on fair food delivery. There seems to be, yeah, okay. So I think this audience already knows about the impact of algorithmic decision making, which has been in the society. So any major application we look at, like ranging from banking, employment, judiciary, healthcare, these are very important socially relevant domains, but there are now algorithms which are being deployed to assist or sometimes like fully replace human decision making. Moreover, there are several new domains which have emerged due to algorithmic innovations like social media, content streaming, e-commerce, sharing economy, and so on. The thing is, which some of the earlier speakers have also highlighted, that as algorithms are becoming pervasive in our daily lives, there are concerns about biases in these algorithmic decisions. And there are some prominent examples which have been highlighted in the past in media reports in academic circles. For example, in case of employment, Amazon had to scrape a recruiting tool it was developing after it showed biases against women. A recent science paper actually highlighted that there are healthcare algorithms which are used in the US. They are biased against poorer groups. Now, in the US context, generally there is also a racial correlation, so it is biased against African Americans. And this particular example got highlighted much more than any other things. So there is an investigative journalism organization called ProPublica. They found that a particular tool called Compass, which is used in US judiciary to help US judges to make bail decisions. So those algorithms are biased against African Americans. Now, the solution is like what people are proposing, and there has been a lot of push from both government and industry. In fact, our own NITI Aayog has National Strategy for Artificial Intelligence. Also, I'm sure that we'll be hearing more about the responsible AI, the draft which has come out, and the push is to incorporate fairness in this AI algorithm. And as I mentioned, like this is not only from the government, sometimes also from the industry. They are coming out with their own fairness guidelines and so on. However, if you look at all this, like the focus largely is on single-sided platform. Like what I mean by this, where we think about the algorithm as a decision maker, and there are users who are taking or either benefiting or they are being deprived of from the decisions made by these platforms. Whereas a lot of platforms which we use in our day-to-day life is essentially multi-sided. So for example, when we talk about ride-hailing, there are drivers and passengers. So we sometimes use the service of a driver when we go into the system, but the system is basically mediating between drivers and passengers. And similarly, when we go to Spotify or YouTube, there are basically artists and listeners. And the same is true for even e-commerce, where there are like sellers, producers, and buyers. And since my focus is on food delivery, which is even more interesting because here there are restaurants on one side, customers on the other side, and the drivers who actually deliver the food from the restaurant to the customer's home. right? Now, if you look at any of these platforms, there are algorithms, more specifically search algorithm, recommendation algorithm, matching algorithm. They determine the economic opportunity or livelihood of people. So, for example, again, in case of food delivery, restaurants will not get enough orders if the algorithm is not somehow suited to treat that restaurant fairly. Similarly, drivers are not going to get any order if the driver is not matched to an order. So, like the driver will not have any income on that day. And the goal of my research has been to develop algorithm all these stakeholders, different stakeholders. And I'll just directly come to food delivery, but I have worked on multiple different platform algorithms. So in food delivery, like there is a huge hype. We know about the Zomato share price, like which is as of today, this is more than 50,000 crore valuation, like the market valuation of Zomato. There are Swiggy, DoorDash, and a lot of other big companies. But the key question which I am interested in is what about the drivers in this platform? Now, almost every day in media reports, in both in India, in other parts of South Asia, other parts of the world, like even in Turkey, Egypt, South Africa, and so on, we see that regularly these drivers go on strike. Drivers means the delivery people, and what they complain about the exploitation by these food delivery companies. Like one problem is meager pay, other problem is like the working hour is very bad. So we thought of actually looking at it ourselves, like what is actually happening. So we collaborated with a major delivery service provider in India, from whom we got 18 days of food delivery data covering 3 metropolitan cities. And essentially we looked at like thousands of orders, essentially like lakhs of orders, thousands of delivery personnel, and so on. Now, what we kind of looked at is what is the distribution of driver income in this city. Now, what we see is that across different cities, like here I'm showing for this city A, B, and C. Unfortunately, I can't reveal the name of the cities or the operator, but essentially in all the cities we see an interesting pattern that even among the drivers, there are some drivers who are earning much more than other drivers. So again, I am using this word drivers essentially, like although in India not a lot of people actually drive to deliver food. So essentially these are food delivery agents. If you look at the top 20% of the agents, they earned much kind of more than 50% of the total money which was paid for this delivery job. Whereas when we look at the bottom 60% of the agents, they didn't even get 20% of the total money which was spent on it. Now, natural question which we thought about is that is it due to the difference in the operational period, that it may so happen that the low earning agents are mainly they are active during lunchtime, and maybe the number of orders during lunchtime is not as much as the number of orders during the dinner time. So we also kind of looked at this individual cities. We looked at the periods, like we divided the whole day into 3 periods, like lunch period, dinner period, and the other time. And interestingly, we couldn't see any noticeable difference in the activity level of the top earners and the bottom earners. So the question is that what is causing this difference, right? And one of the things which we found, which is causing this massive inequality, is the difference in catchment zone. So essentially, if you think about the any city, let's say divide the city into like eastern side and western side, or northern side and southern side. Now the thing is that there are orders which are sometimes located mostly in one side. So for example, in this heat map, I am showing that the orders are mostly in the west, like southwestern side. So the delivery drivers who are working in that region, who are placed in those regions, they are earning much more compared to the delivery drivers who are working mostly in the northern area or the eastern area. Now, this is something which is a little superficial. So you may wonder that why should it be the case? Because the delivery drivers, if they have bikes or if they have cars, they can simply go to some other region, right? So the reason why, let's say a company like Swiggy or Zomato is not doing that today is that involves cost. So if you ask some driver to go to a region where his home is not located, then you'll have to incentivize. You'll have to say that, okay, I'm going to pay you 50 rupees, but please go there. So what we try to look at is that can we do something on the food delivery assignment problem itself, so that all these things are naturally taken care of, and as a result we can get a kind of a delivery scenario which is kind of fairer to everybody. So if you look at the food delivery problem, essentially there are three components, like or the time can be divided into three components. Like one, the time it takes for preparing the food. So whenever a restaurant gets an order, it needs some time to prepare the food. The second component is that when the order is placed, the platform takes some time to assign a particular driver. The driver needs to reach that restaurant. And finally, the driver needs to pick the food and deliver to the customer. Now, no matter what, this particular time cannot be kind of replaced or cannot be do away with, like the time it takes for the delivery person to go from the restaurant to the customer doorstep, right? What we instead do is that we look at the food preparation time and try to see what are the delivery personnel who can reach a restaurant within this time. So essentially, instead of just trying to find the nearest driver to a particular restaurant, what we kind of do is we try to make an assignment that minimizes the gap between the maximum and the minimum income earned by the drivers, subject to that the time guarantee which is provided by the platform to a customer, that if the platform says, yes, Swiggy tells you that the order is going to reach within 35 minutes, we are going to abide by that. But even within that 35 minutes, we'll try to see whether we can find some delivery person who may not have earned as much as someone else. So essentially, this is how our whole proposal works. So when an order arrives in the platform, let's say to Swiggy or Zomato, we start from a restaurant location. We try to find out all nearby drivers who can still meet the kind of the time guarantee. Yeah, hi.
You have to wind up.
Yes, sure. So essentially, by looking at all these available drivers, we try to assign the driver who has earned the least amount of money so far. And the result of this has been quite good. Like we can see that it leads to almost equal income distribution. It leads to minimal increase in delivery time, and there is no violation. So SLA is essentially the guarantee which the platform provides to a customer. However, the thing is that this particular proposal alone may not guarantee any legal minimum wage, and this has been a thing of major contention in case of food delivery, that a lot of these delivery people who are working, they are not paid the minimum wage which is guaranteed by like the legislature, essentially. So they earn less than like what is the legal minimum wage. So just to account for that, we also proposed kind of an approach or a solution which can predict future demand and can onboard drivers only if the platform knows that it can provide the guaranteed minimum wage. So it's kind of like I take on board a particular driver if I know that I am not being able to give the person the guaranteed minimum wage, then I should not take that person. So that is the basic idea here, that we can selectively pick drivers only if we can provide the guaranteed minimum wage. Now, the last point is that we definitely, at least as far as the gig economy platforms are concerned, we need regulations. Now, there are many technologists who are against regulations. They sell regulations, kill creativity. But at least in this kind of setup, my opinion is that, like, unless regulations don't kick in, it will not force innovations to work under these regulations which are going to be there. So with that note, thank you, and I'm open to take any questions which you may have.
Excellent. The questions for Abhijit? I have many, but I can ask offline over coffee, perhaps.
Yeah, sure.
Are there any questions from the audience?
Yes. I think I can hear you. So, yeah.
For this presentation, question I have is, so when you actually try to see the wage more equity in terms of the money they get, that might, have you looked at other kinds of implications, like for example how much fuel they spend?
Right.
Okay. And also, for example, how good an idea, for example, if everybody is giving food in 25 minutes time compared to somebody is getting food in 10 minutes time, besides only a few are getting in 25 or 30 minutes time. So compared to those two scenarios also. But also one more comment I have, actually probably would like to probably, this basically is a very nice idea for a more equitable society. And the idea which you have done, which you already might know, is basically the Leximin ordering of the Rawls theory of justice.
Right.
So which basically, does that difference principle.
Yes.
So who has the minimum would be to get the first.
Exactly. Yeah. That has been the kind of the guiding principle here as well. Yes.
Okay. Thank you.
Yeah. I think this is a little, maybe it requires a little detailed discussion. So just very briefly to touch upon that, yes, we did look at the kind of the fuel cost it would entail. And that piece also was the reason why we wanted to go beyond the proposal. In the new proposal, what we try to do is that we try to minimize the fuel cost, but still want to ensure that everyone gets the fair wage by dropping the needless workers. So sometimes what is happening is that today, like a lot of people may just wait outside restaurants who may not even get any order today. And because these companies has a large swathe of data, it can predict pretty well that what is going to be the order size for that particular restaurant or for that particular region today. Because based on the time of the day, whether it's a weekday or weekend and so on. So what can be done essentially is that it can inform that, look, today the likelihood of you getting ordered is less. So just don't come to this job, you can take another job. And in fact, this is something I just saw that either Zomato or Swiggy are kind of allowing that a particular delivery person can take up other jobs as well. So that like they can switch works, like let's say they can deliver for Instamart or some grocery delivery during that time and then come back to the Zomato thing or Swiggy thing after, like once it kind of predicts that there are more jobs which can be given. Yeah.
Okay, so maybe I'll put in one question, right? So the technique that the problem that you discussed is falls. It's sort of traditional computer science, assignment, pair scheduling problem. It's a scheduling problem, right? So we're bringing standard, traditional graph, integer programming. Those are the kind of techniques that we provide. Do you think that the fairness problems become more complicated when we deal with discrimination, which is not an issue here? So this is an issue of scheduling, perhaps, right? So when we have issue of discrimination and group discrimination, individual discrimination, calibration, that's when fairness becomes trickier. Would you agree?
It depends. So I think the reason I would agree to certain extent. The main reason is that somehow the other models which are at play, like exactly the kind of scenarios you mentioned, right? Some of they have become so complex that it's very difficult to find where you can even intervene if you want to make something right. Whereas, like in the kind of systems which I just talked about, there are still like old algorithms which are at play, right? And you can
I can mathematically formulate it.
Exactly. So, especially like complex deep learning models are very hard to intervene with, right? So, yeah.
Okay, thanks.
Okay, thanks for the question.
The next speaker is Dr. Anna Roy. She's a senior advisor with NITI Aayog. Everybody knows her, and so she'll talk about responsible use of AI, emerging technologies.
Yeah, sure. So you can. So I believe Dr. Anara is not present virtually at this point. We tried to reach out and he doesn't seem to be available at this moment. Even Shri Apar Gupta is also not will not be joining for the
No.
session.
Oh, so then why were we rushing? Yeah. So,
Yes, sir.
maybe we can give some. So maybe we can give some time. Yeah, I was hoping to listen to both of them. So maybe we can then have a discussion amongst ourselves a little bit, right? And we can probably start by taking questions from the audience, more questions, and asking the speakers, all of them, myself included, to respond to.
Yes, we can do that.
We can do that for 5-10 minutes. Yeah.
Yeah, so I'm still kind of intrigued by Smriti's work there. I would like to know a little bit more on the kind of results which you got, because you just talked a little bit about the gender classification, right? So one particular thing, so your observation of FIS++ might be just due to the fact that these models are mostly trained on Chinese or more like Asian-looking citizens or people, right? Now, but apart from that, did you see anything else like which you kind of found to be quite like striking, or it may not be like fully statistical significant at this point, I know, because of the small sample size, but still, do you see that there is something interesting which you may be able to share?
Thanks for that question. So yeah, on FIS++, you are right. You know, we are expecting that it is about that same race bias kind of which has crept in because of the training data they may have used. But interestingly, the two prior studies that we compare our results with, they are not on Chinese or South Asian or Southeast Asian faces. Those are based on a data set of European and African faces. So even there, compared to Indian faces, they do perform better on other foreign faces which are not faces of the country from which they belong. And the other thing, the reason we chose FaceX as an Indian company in this whole exercise was precisely for this reason, because we wanted to see whether is it that an Indian company would be taking more Indian faces into account and therefore might perform better. But we actually found that it performed the worst. It could be because it's a smaller company compared to all the others, so the kind of resources and training that's going in is lesser. But we did find that it did perform the worst out of the four companies that we studied.
So how is this tool performing for European or African faces? I mean, this particular company?
The FaceX Indian one, we haven't applied it to that. Yeah, but that might be an interesting question to look at.
Because that might actually answer your hypothesis, right? Like whether it is due to kind of the lack of technical expertise, or it's just like there is some other fundamental issues which are at play.
Yeah, it's worth doing.
So, okay, so now that Smriti is on the line, let's ask more questions to her. So, face recognition is something that I myself worked on in 1993, 94, published a few papers, and fortunately promptly got out of the area. So, so face recognition, because of the many things that you have said, is problematic. So the reasons it's problematic, there is got a potential to discriminate in a policing application. There are false negatives and false positives. Both are possible. And given the false positive and the false negative rate, the interplay with Article 21 in the policing application is really problematic. So there are issues. There are all kinds of issues that lots have been written about. So let me turn it around and ask you that: do you envisage any application or any situation where face recognition, large-scale face recognition, may be kosher? How do I evaluate, or under what circumstances, or what is the bound that if these conditions are met, then face recognition, deploying face recognition is all right? Can we think on those lines?
Yeah, I would, go back to the fundamentals of why it is problematic in certain situations and then think about whether we can reverse those situations. So one, the absence of informed consent, right? So something like facial recognition on your device, because you have a choice to use your biometric fingerprint, to use your face, to use a code.
On your device is not facial recognition. On your device is facial matching. It's verification. So there's a difference. Facial recognition is a trickier one. So on facial recognition, so can you think of a case under what circumstances? Facial recognition means no consent.
Yeah.
It cannot be, because anybody can come in for example, suppose I'm a criminal. There is no way I'm going to give you consent to put face recognition in me. Right? I mean, so consent is surveillance.
Right? There could be consent in something like border controls, like that is facial matching which is happening, but there is consent and it's kind of become part of the course where everybody kind of accepts it now that if you're going to travel internationally, it is happening.
It's not consent, it's perhaps a law that you have to submit to, right?
Yeah.
So, what makes it safe in those applications?
I'm not sure. Yeah. I haven't studied the what kind of safeguards are going behind it, but I would assume if there is an international treaty which is allowing countries to use, I don't know if this is true, but there may be.
As a technologist, let me tell you that the face recognition system will have false positives and false negatives. There's no way to avoid it. It will discriminate against somebody. There is no way I am going to collect data that will produce the same rates for every protected group. That's not going to happen. So it is bound to discriminate. So it is bound to be unfair, as our Indian will prove in a theorem, right? But Kleinberg and Kuldikova, they have all shown that it's bound to be unfair in the strictest sense of the word. So even all those, so are there any conditions under which government can deploy face recognition? Not on my own. I can always deploy face recognition. That's, for example, in the lab, outside we deployed face recognition. For a small number of people, attendance system, nobody complained, that's fine, right? But I'm saying large scale deployment with the government, under what situations it may be considered safe. So see, unless we answer these questions, we will forever keep fighting. Government will say that this is all right, you will say it's not all right, and I'll be the judge sitting in the middle. So I am just asking that how do I play my role?
Yeah, so even in the criminal justice system, right, which I think is one of the most popular but egregious use cases of facial recognition, the one way to think about it, and it's very hard to implement, I don't know if it's practically possible, but to make a distinction between, what severity of an offense will you deploy this kind of technology in. So not doing it, say, for a theft, versus doing it for a murder. Now, I know there are very serious problems about ensuring access control, making sure this really happens, but that's one sort of way of a mechanism that, you have the benefit of the technology, you don't, there might be actual genuine crimes, a terrorist offense, etc., where you want to deploy it, but in the name of those offenses, if you start deploying it for anything and everything without control, which is probably where we are today, I think that is where, all of us from the civil society worry are coming from.
Yeah, that is surely true. Any other questions? Anybody else? Maybe to Isha and Professor Kathuria? No?
Smriti, I just had a quick question. So while you were doing this, and in terms of were there any jurisdictions where you felt that the conversations are more advanced, or we could be looking at sort of benchmark in terms of their use of facial recognition systems?
So I think both in terms of use as well as in terms of pushback, there is significant progress both in the US as well as in Europe. Europe under GDPR, they've had certain decisions where facial recognition has been used in schools, etc. There's been a pushback exactly for the kind of the structural problems. Municipal schools have not been allowed to use it. In US, like many people would know, there have been cities that have banned facial recognition in public use, as well as bills. So there's actually an interesting lobby kind of going on, where there's a civil society pushing for bans and pushing for moratoriums, and whereas there's the tech companies themselves pushing for accountable fair use. So there is a legislation in the Washington state where it's set to be pushed by Microsoft, where it's about transparency and accountability. as opposed to the bans which organizations like the ACLU have been pushing for in the US. But so there is that interesting political economy which is playing out in that jurisdiction, and because a lot of it is happening at the state level, there are a bunch of different responses which are emerging as a result of this push and pull.
Any other questions? Perhaps from the audience? Or among the speakers?
So I think we are done with the questions.
Okay, thank you very much, sir. Thank you.
Yes, sir. Thank you, sir. It was a pleasure having you. And I would like to thank all the speakers who have joined virtually, Professor Subhashish Banerjee, Ms. Smriti Pashira, Mr. Rajat Katuria, and Ms. Isha Suri, Professor Abhinay Chakravarti. Thank you so much. Now, as we have reached the ending of the session, I would once again like to thank each one of you for gracing us with your presence. But before we part ways, on behalf of TIFAC and IIASA, we would like to felicitate you for being our honorable speakers for the day. To present a little token of appreciation, now I would like to invite Ms. Cherry. I would request Ms. Cherry to come up on the stage. And please hand over the presents to Mr. Chakravarti. Thank you so much, sir. Thank you so much, everyone. It was a pleasure to have you with us. Now I extend my sincere gratitude to each one of you. And we will be just having a short tea break, and we'll start with our next session. Thank you.
Thank you.
Thank you. Thank you.
Good evening, everyone. We'll be just starting in next 5 minutes.
Hello? Yeah, good afternoon, everybody. So under the theme session, this digital and sustainability, this session topic now we are going to deal with is digital innovations and approaches for participatory and inclusive development. As we all know, digital technologies and innovations are increasingly critical to the advancement of human development and the creation of inclusive knowledge. The rapid development of digital technology or innovations around the world has given both an opportunity and a challenge, especially in the developing countries. While digital technologies have grown by leap and bounds, whereas the broader development benefits from using these technologies have still lagged. So our panelists today will discuss about various approaches in this direction for participatory and inclusive growth. And to chair this session, we have distinguished Professor J. Adi Narayana. I would like to call him onto the dais, please. Professor J. Adi Narayana is an Institute Chair Professor in Center of Studies in Resource Engineering, CSRE, and IIT Mumbai. His expertise lies in agro or rural informatics, in decision-making and precision agriculture, using multimodal disruptive technologies like remote sensing, GIS, geographical information systems, communication and dissemination technologies, sensor networks, Internet of Agriculture and Things, and crowdsourcing, UAVs and plant genomics brought a wide knowledge. Sir, please take the seat and you can start the discussion and you may call on speakers. The floor is yours now. Yeah, please.
Thank you. Am I audible? Is it okay? Yeah. At the outset, I would like to thank the organizers for giving me this opportunity and interacting with the young minds here. Well, friends, this topic is really catching up a lot, and this has, as the organizers said, it has a lot of meaning, a lot of importance these days. And if you see here, the gamut of topics in different domains, including from agriculture to road infrastructure and things like that. I mean, that shows the importance of this topic or session. And also, you also agree that what we require is an integrated infrastructure, not just only from the devices, but not even the human infrastructure, I would say. That's a very important thing that we need to think about this. Maybe it will support more innovations, no doubt about that. It will also help to reduce the informatics and cultural, informatics and sharing culture. That's exactly what we lack right now. Can we make these systems open? Can we give open solutions to the folks actually who are looking for it? So that's very important. It also helps, of course, in the process, this inclusiveness and things like that, what the topic says. Thanks to data policies that we have it right now, of course, it's evolving, it's dynamic, because the subject itself is a dynamic one. And also the government actions that is being taken care, like we have Digital India and things like that, is actually helping us in making solutions more open, right? Without much ado, I would like to take first the roll call of the speakers that we have it so that we can manage the timings accordingly. Can I call upon Sri Pradeep Agrawal? Sorry, there are delegates who are online, so all are welcome to this session. Can I call upon Pradeep Agrawal by any chance around here, both offline and online? Is and there's Anshuman Goyal. Yes, he is going to be there in person, physically. Vaibhav Sharma also, I'm told he is not going to be there. And Professor K. Rao from University of Delhi is also likely not going to be there. Am I right?
Yes.
Just to confirm, Rahul Kapoor is around. Please come to the stage. Please come. Yeah, please come. I'm happy that generally only the chair sits here, and we do have the delegates who are sitting here. That's a good initiative by the organizers. Thank you. One more, by any chance, we have two overseas delegates. One, Mohsin Ghaffori Astaini from Iran.
He has not yet joined in.
Not yet joined, but most likely
yes,
join.
yes, he will.
And Arun Ganguly from Boston?
Yes, even he will be joining virtually, but I haven't.
Presently, presently he's not there, but he's likely to join.
Yes.
So that's why, friends, we have about 3 in person and about 3 most likely to have the virtual presentations in this session. I think we have 1.5 hours. We have been allotted 15 minutes, but I think you're going to have.
We are going to crisp it a little bit, like around 10 to 12 minutes will be better.
6 o'clock, you're going to finish it so that you can attend the other session also. I think it's better you take less time and give time for more discussions so that we can jot down those policies which help actually in inclusiveness and things like that.
Yes, so we can see that virtually there are like 2 more people, if they haven't joined, so we can utilize that time for more discussion and.
Yeah, but 1.5 hours, about 12 minutes each we can.
Yes.
Right? Yeah. Okay, without taking much time, I'll start my talk. Okay. Excuse me. Can you make this? Okay. Edit mode first of all. ठीक है ठीक है नहीं नहीं ठीक उठ नहीं रहा सिर्फ वहाँ पे जा रहा हूँ दिखा नहीं रहा इसको समझ करता हूँ नहीं आ रहा क्लिक करना ठीक
Is this going to appear? Okay. Just to confirm with the online delegates, am I audible and visible, please? Can anybody say yes or no? I'm just trying to confirm with the online. It's fine. Great. Thank you very much. Friends, I'm pretty happy to share with you some of the insights that we have got from this multi-institutional, which are mentioned here both from national as well as international. And we also given some sort of open science and digital agriculture through our R&D initiatives and all. Well, I'm sure I don't need to tell, it has been dwelled much in the previous sessions, what we require, the kind of insufficient, the outputs that we are going to have, and also the kind of challenges that we have it. We require both economic as well as ecological sustainability. In addition, many of the countries, they do face this informatics and sharing culture. That is one thing which is really helping us to take it as a challenge and then see whether we can make use of these systems to make it more open. Well, the inseparable solution possibly is when the technology meets the agriculture, unlike in conventional methods. I'm sure many of you must have heard about this precision agriculture, which is more sustainable and environmental friendly. That's because you're actually taking the inputs at right time, place, amount, manner, and right type of crop that you grow. At the same time, since we have the gamut of, can somebody help me? I think there is some issue with this. Excuse me. And the kind of tools and technologies that we use, if we use the right tool and technology, we can make it more smarter, more digital, more automated agriculture. And you can see in the graph, it is mentioned from the Journal of Biosystems Engineering, an exponential growth of these, this subject. And you have many options to take from these tools and techniques. The only suggestion, the one what
people have been following in the precision agriculture is when we apply a critical zone and systems approach, right? So because these players act together, they interact together, that's in a critical zone, and we need to identify these linkages. That's exactly what we need to do it in this precision agriculture activities. And if you see closely the precision agriculture cycle, so it definitely requires an integrated infrastructure, as I was mentioning, not just only platforms, tools, and techniques, but also the human resources. And that will help us to assimilate, interpret, and adopt. That's AIA model that we apply to get state-of-the-art, what we call geoinformatics. That's geographical form-based informatics. Well, it may look very complicated, but I would like to mention that it is possible for us to go from AIA model to AIAI. So you can add this new dimension innovations. If we can take these, the sub-modules, where they are connected together, but what my suggestion to the people who want to innovate this one is to have a loop between these. So if we can think of these reinforcement learning loops, I think that will help us to refine our objectives, refine our sensing needs, refine our model, refine our systems and things like that. So that actually helps us to make it more innovative. Well, I took this one from McKinsey. A lot of disruptive technologies. Of course, disruptive technologies are unlike in the conventional, where already the marketplace is there in that. But here you have the business model, you're using the infrastructure, and that actually is helping us to make it more disruptive. As McKinsey and company has given these disruptive technologies, some of them, of course, are conventional these days. People talk about wireless sensor networks and things like that, but now it has been changed to IoTs and all. Like the new ones are also coming up, which is not listed in the McKinsey. The blockchain is the one which increases the trust and sharing between these blocks, where you can play a big role here. Another one which is making inroads in precision agriculture is the genomics and phenomics, which I would like to probably tell once I come to that slide. Well, I don't need to tell to the audience what is this IoT, but what it requires to make it more intelligent is to have that analysis and act. Those are the things which actually help us. For this, if you can combine these tools and techniques, for example, here the AI and IoT together, definitely you can have a better decision making. But unfortunately, if you see the kind of players that you have it in IoT, and see the kind of percentage of that IoT is in different domains, our agriculture, which is rounded off here, is just about 2%. Way back in 2015, that's fine, but even now, it's not more than 3 or 3.5% if you compare with other technologies like wearable technologies and things like that. Well, my pitch here is the precision agriculture is not just about, it itself is a technology, it's not just about AI and IoT only, but what I would like to mention here is to make it underlying of these interactions and processes. If you want to do it in a complicated systems like plant, we need to have this one, which otherwise we may not be able to do it with the standard statistics or our own manual methods. So that actually helps us in integrated infrastructure, which probably helps us into automate and develop innovative models and devices and systems. So some of the things which we have developed, I would like to show you here. We talk about inclusiveness. Inclusiveness is one such model from Ministry of Electronics and IT of Government of India. There's one Information Technology Research Academy. So that is a really interesting model. ITB being a mentor, and we do have some mentees like our own sister organization, IIT Hyderabad, and local agriculture universities and local agriculture engineering colleges. You include them In addition, we have also included the industrial partners, which are helping us in giving us more sensing needs, and also the actual user, that's MOGA, Maharashtra Orange Growers Association. You must have heard about this orange Nagpur Santra, is a pretty well-known one. Unfortunately, this crop is being replaced by pomegranate. That's because there is a disease called ecchymosis, which is water-loving but soil-borne. That people have discovered it. When you actually add more and more water, the disease is going to be more and more. So that's the thing. So, because we develop this interoperable with the data standards, because we are able to get better knowledge discovery, we are able to solve this, or at least regulate this disease because it's an endemic one by regulating the water. That is exactly what is being done in this project, ITRA project. And we established, of course, the critical zone observatory. The other one which we have two novel systems that we brought out is a sense tube, or is also known as sense cube. It's a standard-based, interoperable, and onboard storage enabled and edge analytics device. So you are getting the solutions almost in real time and at edge itself. That is the novelty of this one. Plus, we also given the two interfaces, like in web as well as in mobile-based agro advisory services through this crowdsourcing platform, with or without expert, by using text data mining and things like that. We are also, when you are talking the end users, obviously we need to think about the local language. So since it is in Maharashtra, so we developed this one in the Marathi language also. Can I set a time? Just check. Another project we have is, I think I have just about 3 minutes. DSFS, Data Science-Based Farming Support System for Sustainable Crop Production, particularly to tackle these climate change aspects. We are using integration of high-end IT as well as agriculture systems. So we are participating in optimal crop management and high-performance plant breeding. As I was mentioning about, the plant phenomics, I will talk about that. Well, we have established this one in an agriculture form to make sure what we are doing is, validated and things like that, so that before actually reaching the farmer. So we established a critical zone observatory here, and we took both nitrogen and water, which are very important as well as climate change is concerned. We did drone-based data, both RGB as well as the hyperspectral. We took the ground truth data, extensive ground truth data has been done. We also did the analysis, and we followed certain process-based models to simulate what we are doing is correct or not. The drone looks only from the canopy, but we added, the advantage of the drone is you can get the architectural information. So that architectural information, we introduced this one in this drone data, and we could get the true leaf area index. That's one of the important biophysical parameters as far as the yield is concerned. We understood the science or the interaction between the protein as well as water, that is nitrogen and water. We developed new vegetation indices because of this water tones, what we are seeing it here. We could able to differentiate, the water and nitrogen. Well, another area which is really growing in the precision agriculture is the plant phenomics. As you can see in the graph, it's exponentially growing. Phenotype is nothing but environment plus genotype. It's very difficult to do it. Typically, the plant breeders take about a dozen years for them to bring out a new variety. because of the policies and things like that. So whereas this AI is helping actually to reduce this and or you can say accelerate these plant breeding aspects. We do have this national or international level, the platforms for us to get our comprehensive assessment of these. Typically the breeders, they call lines, the genotypic lines. Right? So our interest is to say whether we can bring out a drought-tolerant crop because we are dealing with the semi-arid tropics. So that's the one where low early vigor and better use efficiency crops that we can do that. We develop the platforms, grouping them and identifying them based on biophysical and biochemical traits that we can do it with the help of artificial intelligence here. Yes, as I was mentioning, benchmarking of the data is also important. We brought out these open data. People can use that, visit that, download, and then they can, utilize this data on various aspects in this DSSS project. We are also trying to use, the virtual plants. The photosynthesis is one of the important parameters, processes that the plant requires. Here we are trying to virtually create that environment to see that whether you can have better photosynthetic harvesting so that you can have better, our main intention is to tackle the small scale farm holders, assessment of crop residue quality, that is in terms of nitrogen content in stover, as well as the quantity, the biomass, particularly for livestock, which is very important, particularly in the semi-arid tropics. Well, I'm not going into the details about this, but does data speak volumes, or do we need volumes of data for digital agriculture? That's the question probably you can munch on and then let's discuss in case if you're keen. Well, friends, I'm just trying to end this talk by giving some takeaways. We have a lot of opportunities here, and we're also trying to develop scale-independent precision agriculture, as I have highlighted here, rapidly, inexpensive, that's the most particularly in the agriculture systems, and possible in near real time, with profitability and bringing out SOPs, standard operating procedures, like we have it these days in COVID, and policies and sustainability of small-scale farming. That's our target in this very interesting and very competitive project called Mirza scheme from SCRBDST. It does have, but my intention of giving this, the point, green to digital revolution is what we need to think about, particularly in the agriculture systems, is this smartness, not just only intelligent and smartness, but scientific, marketable, affordable, reliable, and time-saving infrastructure for better implementation of the knowledge-intensive and digital agriculture. Well, there's no doubt it's an interdisciplinary. There's nothing like any subject, particularly the grand challenge areas of precision agriculture. It's not just only with the agriculturists now. Definitely, it is an interdisciplinary. We need to involve this inter-stakeholder. That's our main experience from these multi-national and multi-stakeholders projects. That includes the inclusiveness, and definitely it improves the informatics and sharing culture because of the inclusiveness that we have it in the ground. That's it. I would like to say, friends, thank you. And if you're keen, you can use this book for you to understand more on digital agriculture. I will stop here because I have already taken about 3 minutes more. We can discuss if everybody agree at the end of the session. Please note down the questions, and you can ask in general or to the speakers now. Now call upon the next speaker, Mr. Goel, Anshuman Goel from JGU Sonipat. Thank you, Mr. Goel. Please come. Friends, this gentleman is from Jigawa Global University in Sokoto. And his guide is here. May I know your good name, sir? Sudeep. Okay, so he's also there, and you can ask any of you. Thank you very much. Yeah.
Good evening, all. So before I proceed, I would like to call my PhD supervisor, Dr. Sudeep Patra. He would like to introduce the topic, and then I will go through the presentation.
Thank you very much. We are very glad to be here. Now, this particular topic actually is a kind of bridging between policy decision making and human algorithms. Very much needed, and the whole conference is based on the related topics, as Professor also just mentioned, integrated system learning, etc. For me, I will just say that my part in this joint work is mainly developing the mathematical modeling part of it. So this is often called as to be quantum-like modeling. Quantum-like modeling is basically extending certain interesting mathematical tools in quantum science to human decision making and cognition in general. By this, we do not mean any quantum brain hypothesis or such that. We are agnostic about it, but it's mainly a mathematical approach. So that is my own input to Angshu's thesis, but Angshu's thesis is like much more about than this. So I will just hand it over to Angshu to take over. Thank you.
Thank you so much, Dr. Patra, for introducing the topic. Yeah, so as you can see, the topic is the study of bias in human algorithm interaction in policy decision making using quantum-like framework. So AI, AI no doubt has led to accuracy, efficiency in decision making. However, we all know that AI is actually a double-edged sword. AI has also led to many biases and deviations in decision making. So the purpose of this lecture is to actually formalize those AI biases using quantum-like framework. So this is the innovation that we are bringing, the quantum-like framework, which is a part of mathematical psychology. And it also borrows from quantum mechanics. I need to go for... Thank you. As you can see in the background image itself, that is facial recognition algorithm at work. And these facial recognition algorithms have become very common, especially in policing all over the globe. And they also are bringing many biases. So we need to study those biases using quantum-like framework. So first let us study what is this problem of AI bias. If you look at this table of error rates in gender classification, you can see that there is so much of error rate when we are trying to classify dark-skinned female. like it's 20.8%, 34.5%, and compare it with the error rates in dark-skinned male, just 6%, right? Just 0.7%. So you can see that algorithms are very much biased. They are very much having gender bias, color bias, race bias. So, and just to quote another example of Amazon's AI recruiting tool, you know, it was downgrading women's CVs. It was preferring men above women. So AI, Amazon's AI recruiting tool was also having this inherent gender bias. So then we asked, why is this happening? Why is there so much of bias in artificial intelligence? So there are two schools of thought. One school says that, you know, the data itself is biased, and when you are training your algorithm using that data, so the algorithms are also biased. Then the other school says, no, the problem is not actually with the data. The problem actually lies with the software developers. It is the coded bias. It is the human bias within the software developer. And that, because of that, AI bias is also coming in. Now moving on to the problem of second, which is human bias, the second problem. So several studies have shown that humans actually have two kinds of biases. One is the inward bias, which is also called as cognitive bias. The other is the bias from outside, the environmental bias. So cognitive bias, the term has been coined by Nobel laureate Daniel Kahneman, and common biases within cognitive biases include anchoring effect, confirmation bias, overconfidence, availability heuristic, and so on and so forth. The other kind of bias, which comes from outside, that can come from anywhere. It can come from environment, society, religion, politics. You know, in India, we have problem of communalism, casteism, racism. So those kind of biases also play their role in decision making. Now, when we combine both algorithmic bias and human bias, we get a very dangerous kind of hybrid kind of a situation, which is called as bias in human algorithm interaction. What is this human algorithm interaction? It is actually the time, it is actually the processing of the AI advice, how the human is perceiving the AI outputs. That is human algorithm interaction. And some specific biases in human algorithm interaction that we found in the literature, they include automation bias, algorithmic aversion bias, black box paradox, order effect bias, and so on. Our lecture is going to focus on order effect bias. So order effect bias is nothing but, you know, when the response changes as per a change in the AI advice, the order of the AI advice. For instance, the bureaucrat is getting advice from the algorithm, say A1, and then she's getting A2. So A1, A2, this is the order, and that leads to particular decision. When you reverse the AI advice order, when you say it becomes A2, A1, first A2, then A1, the algorithmic advice, then the mental state also changes, and hence the decision changes. So this is the bias, the order effect bias, that we are going to formalize using mathematical quantum-like framework. And then there have been many studies on HAI bias in general. A recent review also gave 20 such biases, such as confirmation bias, reiteration effect, availability heuristic, exposure effect, and so on. But we are going to focus more on the order effect bias. Again, this contextuality in decision making. So apart from algorithms, contextuality also plays a major role in decision making. By contextuality, we mean the context of time, context of place, context of the type of organization, whether it is security organization or whether it's welfare organizations such as children's services, women's services. So based upon the context, the decision-making changes. For instance, in steady and stable context, say at a headquarter level or secretariat level in Government of India, bureaucrats generally follow rule-based decision-making, which is of Weberian type. However, at street level, they are working in very complex environments, so they work more by intuition than actually by deliberation. So when the context changes, their decision also changes. Similarly, in recent studies, it has been found that human algorithm interaction is much fair when it comes to welfare services. However, human algorithm interaction is having a lot of bias when it comes to police or security organizations. So again, context is playing a very key role in deciding the decisions of bureaucrats. Therefore, we can conclude that it is the context that decides ultimate choice making of the bureaucrat. So now we have the context, we also have algorithm. Both of these things are playing a major role these days in decision making at policy level, even at the street level in bureaucrats, among bureaucrats. It has also been observed that just before a decision is taken, there is ambiguity in the mental states of the bureaucrats. For instance, there was one such study in the UK by TIFAC-IIASA. She found that 47% of bureaucrats, they showed both biases and expertise. So both these things were happening simultaneously. So it was like a superposition state. Even in UK, it was found that the police is having many kinds of mental states at the same time before they make a decision. They have states like automation bias, algorithmic aversion, even algorithmic reification. And it was this algorithmic reification was pointed out in a recent study in the UK. So we see that before decisions, the bureaucrats are having so many mental states altogether. So this is like a superposition. And it reminds us of quantum-like modeling, because quantum-like modeling is also based on superposition principle. Now, just linking the AI bias with sustainability. So we know what sustainability is. It is about inter and intra-generational equity, and it is anchored on 3 pillars of society, economy, and environment. The aim of sustainable artificial intelligence is to ensure fairness, equity, and ethics in society. We all know that. And sustainable AI is about, it is as much about the technology of AI, it is also about how the AI advice is processed. So sustainable AI is also about human algorithm interaction, how the human or how the bureaucrat is actually processing those algorithms, the advice of the algorithms. And recently it has been found that AI acts as an enabler in 79% of SDG targets. We are having 169 targets, and AI acts as an enabler in 79% of SDG targets. However, it also shows that in more than 20% of the cases, AI is actually inhibiting SDGs. So that is why it becomes a concern for us. Now, going to specific SDG targets, SDG 16 on peace, justice, inclusive institutions, it is being targeted because of AI bias, because of AI advice. There was one such study in the US, AI advice on bail and sentencing says that black people are at a higher risk of reoffending than white people. So AI was actually biased against black people. And recently there was a study in JNU, and they pointed out that there is so much of data bias and institutional bias in Delhi police against certain minorities. So that is why it is clearly going against SDG 16. When we look at other SDGs, such as SDG 5, gender equality, SDG 10, reducing inequalities, clearly human algorithm interaction bias is inhibiting all these SDG targets. And one such study showed that AI inhibits 59 targets out of 169 targets. That is 35%. Now, in order to quantify, in order to formalize these biases, we are making use of this mathematical framework borrowed from quantum mechanics, which is called as quantum-like framework. Earlier we were using classical probabilities, and it was not able to take into account all those deviations, biases that we are observing today. But quantum-like framework, it's actually taking into account all those biases and deviations by using quantum probability, by using superposition principle, by using various tools in quantum-like framework, such as Poincaré sphere, Hilbert space modeling. We are actually able to devise mathematics, and we can actually formalize these biases, and we can predict how a bureaucrat is going to behave in a certain context. then why this QLF is important? This QLF quantum-like framework becomes important because it can formalize very accurately the psychological ambiguity, the superposition state that we talked about, the mental states having 2-3 things at the same time within the mind. So it can actually formalize psychological ambiguity by using Hilbert space modeling. Secondly, it can also formalize the measurement of cognitive state. It can actually tell us what kind of decision the bureaucrat will make when the bureaucrat is interacting with the outside world, with the artificial intelligence algorithm, with the context, and what kind of decision she will make, the bureaucrat will make. So we can predict that also using quantum-like framework. And third one, we can also formalize the order effect. Since we are focusing on order effect bias in artificial intelligence, we can quantify, we can formalize the order effect bias. And how we can do that? Because in QLF, we have non-commutative operations. So non-commutative operations, I mean, when we say A plus B, A plus B, the output is same. When you say A plus B or B plus A, right? Because that is commutative. But in non-commutative operations, A operation B is not the same as B operation A. So order effect bias is taken care of when we are using QLF. Then why QLF is useful in policy decision making? So as we have told, in policy decision making, we have contextuality, we have increasing human algorithm interaction, and there are so many unknowns, COVID pandemic, we couldn't make decisions based on objectivity. So there was a lot of bias coming in our decision making. And Daniel Kahneman has also famously showed that when a human being is thinking very fast, there are many biases that can come in the decision making. So when we want to quantify all those biases together, quantum-like framework seems to be a good tool for that. Quantum-like framework tools and principles like non-commutative operations, Hilbert space modeling, quantum probability, they can be used to study the bureaucratic mind. Sure. So there has been a wealth of literature on quantum-like framework since 1920s. Pauli and Jung, they also corresponded through letters. And recently, Krennikov has brought books like Ubiquitous Quantum Structure and Quantum Social Science. And there's a wealth of literature on quantum-like framework. For quantum formalism, we are using Hilbert space modeling. Hilbert space is nothing but an abstract vector space that allows infinite sequences. So it can very well model the infinite mental states within the bureaucratic mind. That is why we are making use of Hilbert space modeling. And our mathematical framework is having these 4 steps. We are using Bohr-Kantian epistemology. Then we are going towards the Poincare sphere for geometric representation. And then the context and the AI advice, we are studying it together so that we get the observable mental states. And finally, we are using the Luder's projection postulate for measurement of the mental state. Okay. So this I am just showing like how we are actually mathematizing, how we are using the formulas. Like for phenomenal mental state, this is ket psi in the context of C and in the context of AI advice A. So when we actually when we take a different context, say C dash, so then in quantum-like framework we can show that ket psi CA will be different from ket psi C dash A, because these are 2 different subfields. These are 2 different subfields. That is why ket psi CA will be different from ket psi C dash A, and hence we are able to formalize using mathematics. Similarly, question order effect also we can simulate that very beautifully using mathematics, because ket psi CA will be different from ket psi CA dash, and hence we are able to formalize the order effect bias. So these are just some of the mental states that we found in the literature, from human algorithm interaction satisfying to hybrid bias, and some of them were actually destructive and they were unsustainable, and some of them human algorithm interaction was also constructive in some of the contexts. So the Poincare sphere is basically a geometric representation, and Poincare was a French mathematician who developed this model. It was actually initially used to represent the polarization states of mind, polarization states of light, but we are using it to represent the quantum states of the mind. And this is the equation of the Poincare sphere. And each point on the Poincare sphere represents the pure state, the quantum state. This is the Poincare sphere. The point 2 theta 2 phi lies on the Poincare sphere, and 2 theta is the polar angle, and the 2 phi, that is the azimuthal angle. Finally, Ludus projection. This is used to actually finally, measure the cognitive state of the bureaucrat. And we are using a belief vector L, and we are taking an orthogonal projection along that belief vector L, and hence we are able to find out the actualized mental state of the bureaucrat. So policy implications of such a study, on AI ethics, policy implications can be broadly divided into two. There has to be a change in the AI technology itself, and secondly, there has to be a change in human algorithm interaction. We can have a change in human algorithm interaction by focusing more on administrative training in artificial intelligence and machine learning, and that will create more, awareness among our bureaucrats about algo bias, about human bias. So this can help in reducing biases as we go forward. Thank you so much for listening. Thank you for patience.
Thank you, Anshuman. Very interesting one. QLF like, but of course you have shown some real-time case studies from based on the novel you mentioned here, emerging literature, right?
Yeah.
Thank you very much. So we'll have questions maybe in the end. So can I call upon the next speaker? Is my neighbor here, Sri Rahul Kapoor, the Director of Ministry of Housing and Urban Affairs in New Delhi, Government of India.
Presentation is there. Okay. Thank you so much. Okay, I'll get 10 minutes then. So to go very quickly, I bring in a different perspective, a perspective from the Government of India's side, not from the academic point of view, but as policymakers, what is the kind of strategic approach that we need to take when you are looking at the urban sector, which is so important today. India's since independence, primarily we had been rural. Even today, most of the population does live in the villages. But urbanization is a very important and growing trend. It contributes nearly 65% to the GDP of the country, with nearly 34% of the people living in urban sectors, and it is expected to grow. So looking at that, how do you address the urban challenges? Because we do have a 1.4 billion population. And looking at that, the rural-urban migration that is taking place, the kind of urban challenge that we all face of congestion, of pollution with regard to housing. So the whole way we do policy, the way we basically make or take decisions, that needs to be fed in by a lot of evidence. And sometimes, as was pointed out by the previous speaker, that as government servants or as an authority, we sometimes take a lot of decisions on intuition. And as I would probably say that Mr. Demings once said, in God we trust, but for the rest, please bring me data. So when we're talking about urban outcomes and how do we need to measure them or why do we need to measure them, it is basically to meet the aspirations of the people. And when you're talking about meeting the aspirations of the people, you and I as citizens would probably look at three things while we are deciding on what city we would want to be in. So if I have decided to be in a city of Delhi, probably it's being able to provide me with better quality of life in terms of better roads, better education, infrastructure. It gives me economic opportunities by way of better jobs, livelihood opportunities for many of the people who want to migrate to cities. the whole agglomeration benefits that come about, the way it's able to create growth opportunities for people. And of course, sustainability. When we are talking about how clean or green a city is, the effect of pollution that probably pushes us so many times to probably move out of Delhi and probably settle somewhere else. So looking at these aspirations that people have, it's very important as policymakers to be able to understand what these aspirations are, where we are as a city in trying to meet those aspirations or outcomes, and accordingly perform those tasks that would help us fulfill the aspirations. Now, if you look at this particular slide, it talks about the three outcomes that are nothing but aspirations of the people that we need to understand, that we need to measure, be it the quality of life, be it the economic ability, or be it the sustainability part. And to achieve these outcomes, what is very important is to perform as an authority by providing services, be it urban services like transportation, traffic services, water, education, health, be it in management of finances. How are you able to generate revenue? How are you able to better manage those expenses as a government? Because you have to do more from less. You have limited resources, you have very high population pressures, and with that, you need to be very, very prudent in how you do your financial management. You need to plan better. So when you're talking about city planning, how you're able to avoid congestion through just better transit-oriented development or hyperlocal cities, these concepts that are talked about, which I'll not go into detail. But how do you effectively plan and how do you implement those plans in a more impactful manner? How do you leverage technology? So when you're talking about all the emerging technologies that are there today, be it blockchain, artificial intelligence, the kind of technology that is getting deployed since the Smart Cities mission came about. So we have today like more than 90 cities which have got an integrated command and control center. Now there are several IoT devices, edge devices, sensors getting deployed, a lot of data getting generated. So what are you going to do with this data? How are you going to basically move away from being a vendor-driven push to really meeting the citizens' aspirations and their having a citizen focus? And how do you create the governance mechanism around it? By creating the right kind of enabling environment, by building capacities in the people who are there in the government, by building the right kind of capacities in those people. And so, understanding all these parameters, be it the enabling parameters, so having the right kind of KPIs to understand that, having the right kind of KPIs to measure the outcomes becomes very, very important, and that's where the role of creating an ecosystem becomes all the more important, which needs a very, very strategic kind of approach. And when we are talking about AI, of course, AI would work when you have good quality data, and that's why having enabling data ecosystems around all these sectors that we have in the urban domain becomes very, very key. It's just like, I'll give a simple analogy. As a person, sometimes we experience fever, and we take a paracetamol to basically bring down the temperature. But what we are really doing is addressing the symptom. But what is the cause? So we sometimes go for a medical test and we take out a lot of blood reports, maybe LFT, KFTs, and all those tests, battery of tests that are prescribed by the doctor. And when you go through that report card tells you what the problem is. Maybe it's something to do with your cholesterol levels, maybe it's something to do with your liver function. So as such, understanding the key parameters that feed into the various sectors that are operating in a city become very, very important. So having a report card of that is what is this data ecosystem is going to create. And for that, you need to institutionalize a culture of data. Because we are riddled with very limited capacity. We have people who have not been appointed to have a focus around creating a data ecosystem. So today, yes, you have somebody from the industry, from the academic institution coming and talking about technology. But what is the capacity from the demand side? The person who's actually going to deploy that in the city ecosystem. So how do you build that capacity? So what we did as a Smart Cities mission, one of the initiatives amongst several initiatives that we had undertaken, especially in creating a tech-enabled data ecosystem, was create a data smart city strategy. It talks about basically the three key pillars of getting the right kind of people. So appointment of city data officers was one thing that we did. Creation of data champions, those who understand the world of data and technology. Getting the right kind of people there who understand data, building alliances between the different sectors. And this second analogy that I would like to give, which today people say that data is like the new oil, and wherein we say that no, actually it's like gold, because oil flows, but when it's gold, it's there at one place. So when you're talking about data moving from one place to another, you need to have that kind of an enabling environment also. So you have to build alliances that allows free flow of data to take place. That's how AI systems or AI models will work. And when you're talking about having coordination with other divisions, other government departments, because that's how our whole urban sector is institutionalized on data. So focusing on people, focusing on the processes. So having people who understand what data is all about, what is the data policy all about? I mean, what are the key components in handling issues such as ethics in AI, or handling issues of privacy, handling issues of data security? So if you're talking about drones and how do you want to do drone mapping? So what are the policy initiatives or policy or regulatory mechanisms that are in place? Understanding that, building the processes, creating hackathons and challenges just to create an enabling ecosystem for innovation to take place. And talking about platforms, so like everybody wants to invent the wheel. So instead of that, what if we can actually build enabling platforms that allows all the stakeholders in the urban ecosystem? And I'm not talking about only the government. I'm talking about people in the academic institutions, in the industry, who are able to make use of these common public goods or digital public goods so as to create value out of it. And that's how innovation takes place. Be it the internet, be it the GIS technology and how it has evolved over the years. And the kind of innovation once the US government decided to make it open. So everything from booking your meal on your Zomato, or booking a cab on Ola or Uber, or tagging of projects from project monitoring and evaluation in the government. Everything is GIS enabled, and all that innovation took place outside the government ecosystem. So creating enabling platforms to get all this quadruple helix of government, academy, industry, and the civic society together becomes very, very important. So accordingly, as part of the Data Smart Cities, several initiatives were undertaken by the Smart Cities mission in the ministry. Curbing with Data Maturity Assessment Framework, which tries to understand, it's basically a report card of how data ready are cities today, whether they have the right kind of people who understand data, whether they have adequate financial resources, are they investing enough in capacity building of this team that is there, whether they are having adequate capacity building frameworks available, whether they are building alliances, what kind of insights or use cases they are trying to build, what kind of platforms they are leveraging, having an urban digital mission. So basically, be it providing urban governance services, or be it creating data exchange. So this urban data exchange is a fantastic initiative that we have taken. It's basically like the UPI in the data exchange ecosystem, because today when we talk about the whole evolution of data, so people say that let's open up the data. So it starts with a lot of government departments and institutional authorities basically publishing data, but a lot of data is not published. And as academics, you would definitely appreciate that there's a lot of data that you would like to get access to, but due to commercial reasons or due to maybe security concerns, they're probably not made available. So how do you have a data exchange that allows this access control exchange of data to take place? So creating an exchange in that. When I'm talking about AI, so a lot of concerns on AI, but how do you have a roadmap for city planners and implementers to actually have an AI roadmap? What is the step-by-step iterative process? How do you select a sector where you want AI to be deployed? And after selection of the sector, what is the ecosystem available that will allow you to develop those AI models? So if somebody like Anshuman wants to work with an urban authority, then how does he do that? And what does the city need to do that he's able to, or they are able to reach out to Anshuman? So these are the kind of things that as a ministry, as a policy making body, we are trying to do. Create this whole ecosystem around data and technology, create a whole culture of data through creating a lab, I would say a research lab in the Urban Data Observatory, which we have created, where we are trying to get data from the cities through the IoT devices, through the ICCCs, etc., or be it from satellite data, etc. Moving forward, when I'm talking about outcomes, and because the whole topic is about integrated policy making, and we are saying that data is going to be a very important, is today also, but we want it to be a more important and more robust kind of ecosystem that we want. So all these framework documents that we are talking about is what we are trying to do. We are trying to collect data, have the right kind of KPIs, so that we can do cross comparisons. And what we have done is we have come out with something called the Urban Outcomes Framework, wherein we are trying to capture more than, I'll just finish in 2 minutes. So what we are trying to do is get a 360-degree views of a city, a complete city. So when I was talking about the report card of a city, that's what the Urban Outcomes Framework will do. It will basically give you a snapshot of all the sectors and what kind of data is available there. so that you can do cross comparisons, you can do benchmarking. So just to give you a snapshot, this is what the urban outcome framework would do. Sectoral coverage of 14 sectors with more than 440 plus data points across 250 plus cities that are municipal corporations. And when we scale up, we want to take more and more cities in the foray, because we have today 4,800 plus cities in the country. What we are trying to do is, we are trying to build a technology platform. We called it Amplify. It is assessment and monitoring platform for livable, inclusive, and future-ready urban India. And this is where we are basically trying to create the biggest or the largest urban data bank, wherein you can actually look at sectoral data, create various kind of visualizations, or basically extract this data. And we are trying to make it open to the public and to the academic institutions, so that you're able to make use of this data to create basically insights and use cases that you would want to do. Co-creation and innovation take place. And that's the whole objective of creating a portal like this. So what the Urban Outcome Framework initiative is going to do is, it's going to be a comprehensive database across these 14 sectors. It's standardized the whole process of data collection, wherein how do you create a system wherein this data is captured through APIs, how do you have more cross-sectoral data for research and analysis, for evidence-based decision-making and policy-making, how do you create better collaborations between the various data stakeholders, being private sector or the academic institutions, and also create new opportunities for co-creation and innovation to achieve the sustainable development goals. So with that, I conclude my presentation. Thank you so much.
I think the next two speakers who are from overseas, I would like to get confirmed whether they're around or not, please. Can I say Dr. Astani from Iran? Can you say yes or no from virtual? Okay, what about Arup Ganguly from Boston? Okay, so since they're not there, I think we do have good time for us to discuss. Anybody from the audience? As Dr. Patsarji mentioned, not only to the audience, to the speaker, even to the speaker to speaker. Okay, both from online and offline. If any questions are there, please do not hesitate to ask. Anybody from online participants? Yeah, please identify yourself and then, ask the question, please.
So myself Chandrasekhar, I teach at IIT Tirupati. So my question to the first speaker. Yeah, yes, I do agree with artificial intelligence, machine learning in agriculture. So whatever we are doing is fine. Okay. So my question is that, so all the things we are doing for the welfare of the farmers, or enhancing the well-being of the farmers. So if you look at the other side of the story, because we are always talking about the supply side, and we are believing that, okay, supply is there, that's all the farmers, basically we are coming towards a normative approach that, okay, we should behave that, okay, all the farmers should behave in this way, they should adopt this technology, they should do this. Okay, actually look at the other side of it, I've been told that the adoption rate is very low. You talk about the agriculture insurance after 30, 40 years of the implementation of insurance scheme, even after the Pradhan Mantri Fasal Bima Yojana, if you look at the last scale data collection by the NSS show, the Farmers Assessment Survey report, you find that around 9%, not even 10%, on adopting insurance. Okay. So although the insurance is there for the last 30, 40 years, even other technology you can take, okay, where the adoption rate is very low. There's a demand side, they're not demanding that particular technology. So in that case, so how the supply will help the farmers to improve their well-being? That's the main objective of the supply. Okay. And the second question to the artificial intelligence, second speaker. So since we're talking about that, okay, some of the words we have used from the behavioral economics and Daniel Kahneman. Okay, as you know that Daniel Kahneman is talking about basically about the heuristics. Okay, basically, I still have a doubt that. See, in economics, okay, we have two kind of theories. One is the neoclassical theories, which basically we believe that human brains are basically machines. Okay, they collect all the information, calculate and make the decisions. But who is basically the behavioral economist Daniel Kahneman and Herbert Simon? So they don't agree with that. They basically call it as a bounded rationality, that human beings are not rational. So when you talk about artificial intelligence, okay, actually observing that, okay, how a bureaucrat or anybody can behave, how they are going to behave, okay, means basically you believe that, okay, their brain is again a machine. Okay, that brain is again a machine because because artificial intelligence, you got all the information and you process it. Now, okay, this guy is going to behave in this way because you got all the information. But actually, the entire behavioral economics literature is criticizing that okay, human brain is not a machine and they don't make the decisions as a rational human being. They're basically founded rationality. And also that basically Daniel Kahneman is talking about that, okay, basically how they make the decisions, which is basically completely different than what you are basically talking about, that okay, human brains are not machines. Suppose in that way I can go, so you can, if you can basically get okay, how the XYZ person is going to behave, which is very, very difficult. Okay, very difficult in economics. I know that when doing the field work, talking to the people, how they're behaving today is completely different than how they're going to behave tomorrow or day after tomorrow. It all depends on that particular day and situation. Even in case of talk to the farmers, okay, how they behaved the last year, they're not going to behave in the same manner in this particular year. So how this learning and putting all the information, tell that okay, this X person is going to behave in that manner. So in that way, we don't need the human to behave. Okay, the machine tells, and we don't need the judge to write the verdict. The machine will write the verdict.
So in a way, you want to say it's not just only the machine, but the human involvement also should be there. Is that? Yeah, how do you train that? That's accordingly it behaves.
One is behaving in different ways.
Yeah, so we are not treating brains as machines. That is why we are doing human algorithm interaction. We are actually trying to formalize the biases itself. Since we are talking about biases, Daniel Kahneman and bounded rationality. So that's what we are doing because there was a gap in and that's why we are coming up with quantum-like framework, because quantum-like framework can actually quantify the human cognition, and it is taking care of bounded rationalities, it is taking care of deviations in decision making at policy level. So we are actually trying to create a broad framework. The purpose is not to actually predict decisions. The purpose is to study the biases, not to predict. Since when we can study the biases objectively, then it will become possible for us later on to take corrective actions, to reduce bias, to become more sensitive about bias. Bureaucrats will become more sensitive about bias when we do such studies. And as for future research, we can, once we quantify using mathematics, perhaps one day we can also write code in Python or any programming language. Then we can take the inverse of the function, and in future we can de-bias. We can actually reduce biases in human algorithm interaction. I think it somehow answers.
If I may just add to that, and I really love the point that human beings can never be machines or machines are different. It goes back to Sir Roger Penrose also, which says that there's something non-computational happening in brain, so everything can be reduced to computation. That is very well taken. And that is also what we are also suggesting. We are basically in a description of the biases and what we can learn from that. And also one thing that quantum-like framework is a more, in a way, more comprehensive framework than, say, Boolean logic framework, which has been used in decision making. So that comprehensive nature of quantum-like framework, that is what we are using, not more than that. Thank you.
Yes. Please identify yourself.
Hi, good evening. I'm Shankar Ghosh and I work with the Celestial Earth. It's a think tank. So my question is to Sri Rahul Kapoor. So the problem that we face is not data itself when we are dealing with policymakers, but different versions of the same data. And there have been some attempts from Niti Aayog or some attempts from other ministries to collate all that data in one platform and make it as a universal truth, but it still hasn't happened yet. So making multiple avenues of collection of data, it's probably not required, but making a universal truth which starts from city, ends at state and ends at national level.
Thank you so much. In fact, I think you made a very relevant point. And that was the challenge we were also facing. Even in the Ministry of Housing and Urban Affairs, we have multiple assessments that keep happening at different frames of time. For example, the Swachh Survekshan, which looks at the wash indicators, or the Payjal Survekshan, which is going to happen very soon. We do the ease of living, the climate smart cities assessment framework, the data maturity assessment framework, the municipal performance assessment framework. Now, a lot of data is being collected multiple times from the same single source, and a lot of times it is happening manually. So while we are talking about the urban outcome framework strategy, when we are talking about creating a platform like Amplify, which is an urban data bank, we want this whole data to come validated from a single source at one time. And then we don't want to focus on creation of these frameworks. We are shifting from indices to data in the sense that instead of collection of data as an exercise while doing a ranking of cities, we are trying to reverse that. So when you have a data bank, and tomorrow if you want to understand the maturity or readiness of a city in a particular sector, so let us say if you want to create an index that would help you understand the cities of Maharashtra in terms of environmental parameters, and you probably want some data from energy, some data from, let us say, housing sector, and some from water sector. So you can probably use this data bank and create that kind of a framework for yourself to understand how the cities compare. So at the end of the day, using machine learning, capturing data through APIs, understanding what is the data ecosystem today, building alliances between the various owners and custodians of data on date, and then having a system wherein you don't do a repetitive collection of data and redundant exercise of collecting data multiple times over the period. That is the whole objective. We are trying to build that, and that's the whole objective of this urban outcome framework that we want to create this urban data bank. So I have a single source of truth, at least in the urban sector.
Yeah, is there anything right now, like for the historic?
So this Amplify, of course, it is not open to the public right now, though there is some data that you can probably see when you go online and see the ease of living or the Swachh Survekshan, the entire data that they are collecting on the Swachhtam app. Some of it is made available to the public. There's a Smart Cities open data portal again. But then, like I said, how this evolution of data takes place, so there's also there's a need to identify high value data sets. That's certainly a realization coming in the government that that certain data sets have to be classified as, let us say, of commercial value. So tomorrow, if you decide to have a data monetization strategy, then how do you do that without first identifying and classifying data as high value, or let us say having an exchange which is secured and access controlled? So maybe a data exchange like the IUDX would fit in there. And of course, after that, having an exchange wherein once this currency is attached, this valuation model is finalized, then you can actually do those transactions. That is how it is going to take place. But today, yes, it is available on the smart cities open data portal for smart cities, let us say, which is 100 cities, but not for the entire urban data ecosystem that we're talking about. It's scattered. It is not the most optimal situation. It is there at several places, but the idea is to get it, I would not say create a common platform, but try and get this data through API and have a clear policy on how one can actually get access to such data.
Thank you, Dr. Kapoor. I think we have about 5 minutes. Maybe please go ahead. Please go ahead. Yeah. I'm still, Dr. Baminipati, I have not answered your question. I'm going to come back to that. Yeah, please go ahead. Yeah.
Two quick comments. One is on the conversation between my colleagues here and our colleague at the back. I'm an narrative, by the way, I'm a professor at OP Jindal. The point I want to make is on public policy and the models we use. We were making public policy based on neoclassical economics for the longest while, with all its imperfections. Then we improved a little bit by bringing in behavioral economics. Now we are able to improve a little bit more, but we can't claim any panacea. You know, my colleagues are not claiming that, but we believe that we will be able to do a little better than we were doing with all these crazy assumptions of neoclassical economics and coming forward, and that public policy will be better informed. But the real point I want to make is I really enjoyed Rahul's presentation, and I wondered whether we didn't have a natural opportunity here between the work that Anshuman is presenting and the data that we're generating for us to have a university government partnership which can really be productive. I see some really powerful synergies, and I would like to suggest that, because one of the things coming out of this conference is this great opportunity which doesn't seem yet to be exploited between government and universities. So I'd just like to suggest that we find a way to do that.
The TIFAC can help in this? Yeah. Asked a very pertinent question, particularly when we talk about the agriculture systems. He says the adoption and acceptability, right? That's in the back of the minds when we talk about these ICTs. Is it acceptable by the rural systems? That's the great, that's there in everybody's back of mind. Now, when we actually do any project, friends, and when we deal particularly the complex rural systems or agriculture systems, what we need to do is the needs assessment. You know, we just can't go by our academic model. We need to really think about what exactly they're looking from you and what you can give them. So this is, is a two-way and mutual benefit. So that the needs assessment is the one which is very important. You can't, sort of coerce people, look, you should do this and things like that. Particularly it doesn't happen in the rural systems. I think everybody is aware of it. And acceptability, versus inclusiveness. I think that's the question I think Dr. Baminipati has asked about that. You need to showcase, you need to involve these folks at every significant stage of your model or, project. Otherwise, it won't be acceptable at all. That's our experience with our Maharashtra Orange Growers Association. That's our experience with many of the other projects where you need to include these guys at every stage. Then only it is possible. One question he asked about is the insurance. I want to ask him, has he ever seen these folks who actually give this insurance to the farmers, have they established properly these sensors or, the weather stations? Some of these things are actually placed in the top of the tree and things like that. So how good is that? How can the people will accept that insurance policies if these standards are not followed? For example, when you want to put some sensors, there are some standards which will give you the authenticate information or authenticate data. If you don't follow, always it's a garbage in and garbage out. That's why people don't follow or accept that. So my answer to in everything is an appropriate session here, inclusiveness. I think that is where it matters. And my another thing which I would like to mention, particularly in the complex agriculture systems where I am working, is definitely you need to involve these folks at every stage. Then only it is possible for them to accept and adopt. Thank you very much. If any question is there, I will close this one. I think by 6 o'clock, you have another session here, a common session for everybody to participate in that. Thank you very much, TIFAC, Dr. Bakshi, and others, giving me this opportunity and giving a wonderful, the speakers that we have in this session. Thank you very much.
Yeah, thank you, Professor. So we have concluded this session, and there's another panel discussion after this. This is the end of this day 2. On behalf of IIASA and TIFAC, I would like to offer thanks to all the speakers who have elaborated on digital innovations and technologies and how they are going to make our life easy, however, with some riders and compliances. And just I request Professor Adi Narayana to present a token of appreciation to our speakers. I would like to call first Mr. Rahul Kapoor. Mr. Anshu. And now I call Ms. Sangeeta Bakshi to offer a token of appreciation to Professor Adi Narayana. So thank you everyone. I request you all to join for the panel discussion in the main hall. Thank you everyone. Thank you so much.